The handouts or review materials must be treated with utmost confidentiality. It shall be the responsibility of the person whose name appears therein that the handouts or review materials are not photocopied or in any way reproduced, shared, or lent to any person or disposed in any manner. Any handouts or review materials found in the possession of another person whose name does not appear therein shall be prima facie evidence of violation of RA 8293. Top-notch review materials are updated every 6 months based on the current trends and feedback. Please buy all recommended review books and other materials.
So good day to everyone. First, let me give an introduction to physiology in terms of anong nangyari dun sa last batch. So with the March 2023 batch, ano yung feedback for that physiology? Physiology won't be the hardest. It won't be the easiest subject in the med boards. Hardest subjects will still be anatomy, patho, and prevmed. Easiest will still be micro and legal med. Physio will be somewhere in between. Now, okay? If you're going to take a look at your handout, it's based on Physio BRS. Yun yung ginawa kong skeletal outline, and then dinagdagan na lang natin ng konting Guyton and Hall, Bernin-Levy, feedback of students from the past boards, okay, questions from Physio BRS. So why did I base it on Physio BRS? Consistent since what, 2019, 2018, even before the pandemic, they're asking questions from Physio BRS. Ang nagbavary lang between the boards, between the batches is ilan. Sometimes it can be as many as about 20. So, nare-recognize ka agad ng mga estudyante kapag ganun kadami. Last March, meron pa rin, okay, but it's less than 5. So, some of the students were not able to recognize them as coming from Physio BRS because there are about 200, 300 questions in Physio BRS. So, obviously, some students will not be able to recognize them. Others would. So, when we got the feedback of hundreds of students after the med boards, meron pa rin naman. Okay? Kaso konti na lang for the last batch, around 5. What should we do, Doc? Should we memorize the answers for Physio BRS? Okay? It's more important, I think, to understand the concepts and principles behind those explanations. Para kapag kahit hindi man yan lumabas verbatim, okay, magagamit mo yung knowledge of physiology, okay, to answer other questions. Okay? The March 2023 med boards, physiology, okay, are also marked by repeated questions. Questions coming from previous med boards. Na-recognize din ng mga students yon. So there are around 6. Okay, medyo madami-dami. Kasi usually, ang repeated questions across batches, isa, dalawa lang yan per subject eh. Konti lang talaga eh. But a little bit higher for physiology last batch. Okay? It's not uniformly hard. It's not uniformly easy yung questions sa physiology. Okay? There are some easy questions in the med boards and even in physiology. Okay? For example, before in physiology, they asked what's the basic unit of life? So that is the cell. In the other subjects, they ask, for example, ano yung mga madadaling tanong? What is the scientific name for bad breath? So they ask that in surgery. So it's not all difficult. Hindi siya uniformly hard, uniformly easy. So you're going to find some easy questions in the med boards. Trivial questions are always present. Consistent even during our time. Okay, 2005 onwards, may mga trivial questions. Mga questions na it's not really the fault of the members of the Board of Medicine. It's the system. Okay? We have the Medical Act of 1959. At that time, hindi pa masyadong uso yung quality assurance systems. So, basically, the problem is you have 6 people, 6 doctors, creating questions for the 12 subjects. And there's really virtually no check and balance. No one is taking a look, evaluating whether the questions are good or not, okay, if the quality can still be improved. So you will find trivial questions, for example, in the med boards. Sa mga all-time trivial questions that they asked before was, for example, what is the first documented case of smallpox? So nangyari na yan, okay? Crossover questions are consistent for the past 3 years, ever since the pandemic ng 2020. When I say crossover questions, these are questions more appropriate for another subject that's being asked in that subject. For example, there are questions in anatomy, okay, that can be as many as five questions out of the 100 na hindi tinatanong sa anatomy, nalalagay sa physio. Okay? May mga questions na pampato, may mga questions na pang IM na nalalagay sa physio. So, you should um, remember, hindi kami gumawa ng exam. We're the ones preparing you for the exam. So, this is reality. It's an unfortunate reality na that the questions could have been better. The med boards could have been better created, better implemented. But this is our system. As the water rises, so must the boat. Meaning, we have to adjust. So we want you to be aware of these realities, and we want you to psychologically prepare for them in advance. Okay? Physiology can help in the other subjects. As one of the feedback noong March 2023. Whatever you're going to learn for the next few days, whatever you're going to learn from your handout, almost 100 pages, will help you answer not just questions in physio, but also for other subjects like Pato and IM. Okay? Students, when we did an SGD and when we did surveys after, they really told me, sir, itong physio nakakatulong, pero para pumasok, kailangan talaga at least 2 readings. Hindi pwedeng isang basahan lang, hindi pwedeng walang video. Okay? So you need to watch these lecture videos. Okay? You need to read your handouts at least twice. Okay? Better kung 3 times actually nyo babasahin. Now, some finer details nung March 2023. Okay? Feedback ng mga estudyante. Some choice in the question is repeated twice. So these are errors doon sa exam, unfortunate errors. You cannot really do anything about it. Okay? You just answer as best as you can. Okay? There are double negative questions present in the exam. Like for example, okay, in the words of one student, if fertilization did not occur, which will not happen? If fertilization did not occur, which will not happen? No sloughing of endometrial tissue, no division of cells, release of genetic materials, no thickening of the uterine wall. So in this situation, you have to rephrase the questions. Okay? Rephrase it in your own words. Kasi ang daling malito dyan, ang daling magkamali. And then number 10, okay? In the Medboards March 2023, impossible questions exist. Meaning questions na walang tamang sagot. This is very frustrating for the students. Okay? Halimbawa, what's the function of free ionized calcium? A. Blood clotting. B. Maintenance of blood vessel integrity, muscle contraction, or nerve conduction. The correct answer is actually all of the above, but it's not in one of the choices. So in that situation, what should you do? So we'll discuss that pagdating ng testmanship natin because there's really not much you can do. Okay? The med boards, the Philippine med boards is an imperfect exam. There are good people in the Board of Medicine, but the system is imperfect, and that will reflect in the questions. You do the best that you can. This is the reality, okay? So you make adjustments. We'll guide you. I'll personally guide you, okay? I'll try and make you understand physiology such that kaya mo na ikwento yan sa magiging estudyante mo one day when you become residents, when you become consultants. So watch the lecture videos. Do not fast forward. Do not speed it up. Do not rewind. Pinaka-ideal is you watch these lecture videos using a large screen like a TV or a projector. Okay? Kabit nyo na lang kung may TV na kayo. 55-inch, 65-inch, mga ganong kalaki. O kaya, pwede kayong, you don't need to buy a fancy, expensive projector. Get yung mga mura lang, mga 2,000, 3,000, or borrow from friends na may projector. Project it on the screen. Kung 100 inches yan, iba ang itsura ng mga lecture videos ng top-notch pag malaki yung screen kesa maliit. Please do not watch this on your iPad, on your cell phone. Okay? Preferably use as the best speakers possible, meaning nung loud and rinig talaga yung tunog. Okay? Iba. If you want to mimic the on-site face-to-face lectures, you start with projecting the lectures on a screen that's very large. Okay? And with speakers na naririnig talaga properly. Okay? So, watch the lecture videos, do the handouts twice, just relax. If you're not able to finish within what? The 4 or 5 days allotted for this subject, move on to the next subject. Okay? Babalikan nyo na lang yan as a backlog. Okay? But try your best. Okay? Target siguro mga 25 pages per day or at least mga 2 to 3 the lecture videos. Okay? Pinaka-ideal niyan for me is sabay. Habang nanonood kayo ng lecture videos, sumasagot na kayo ng handouts, huwag nyong i-pause. Kasi pag nasana yung utak mo and sarili mo na nagpo-pause palagi, pause, rewind. Yung isang hour na lecture video, naging 3 hours, 4 hours. Tatagal ka talaga. Kailangan sanayin mo yung sarili mo na makinig, na hindi nagre-rely sa pag-pause ng lecture video. Okay? Na kapag sinabi, kailangan nasulat na alala mo na. Okay? Just force yourself. Train yourself with that mentality. So avoid pausing the video as much as possible. Okay? So let's begin with the main lecture series. We have 8 modules. Okay? Cell, Neuro, Cardio, Respi, GI, Renal, Endocrine, Hema, and Special Topics. Okay? I'll be discussing all of those modules except for Neurophysio. Specifically, the Neurophysio sensations, the sensory system, and the motor system, that will be discussed by Dr. Franz Rubio. Okay? And training him ng CONTEF to teach physiology to the students. The others, I'll be the one to discuss the other modules. Okay? So, 95 pages. Ang ginawa ko dito na strategy, instead of using PowerPoint slides talaga na the traditional, I decided to get screen caps of your handouts. And that will now be the basis for my discussion. So, why did I do that? Okay? Basically, dahil gusto ko, pag natapos kayo sa lecture video na to, para na kayo nag-first reading. Tapos gusto ko, okay, yung handout ninyo, makover ko. I won't be able to cover everything that's in your handout. Of course, I'll try to pick what I feel is those that are topics, concepts relevant to the practice of medicine, and relevant also to your med boards. The rest will be up for self-study pag natapos yung lecture. Everything that you need to highlight, okay, has already been identified for you. We're going to have what we call guided highlighting technique here in physiology. Everything that you need to highlight, naka-bold, italicized na dyan sa handout ninyo. So kapag naka-bold, naka-italicized sa physio, yun lang ang i-highlight. Practicein nyo na. Okay? Ganun yung design natin dito sa program for physiology. Okay? So ready? Okay, so pakiramdaman natin. First module, cell. Let's begin. Okay? Okay, let's begin. First with cell module. Okay? So, previous board exam question of the easiest questions in the med boards ever. So, what is the basic unit of the human body? Choices given at that time, okay, according to the students, were cell, nucleus, mitochondria, I think. So the basic unit of the human body is, of course, the cell, okay, not the nucleus. I'll emphasize that here as the first line in your handout, okay. First step in cell reproduction, DNA replication, okay. So in terms of the number, we have approximately 68 trillion cells. A previous board exam question, tinatanong, okay. Actually, kahit sa med school, tinatanong to. Total number of neurons that you have, it's 100 billion. Okay, yun yung classic na tinuturo sa med school. But actually, when we verified that, okay, sa internet, the actual number is actually closer to 86 billion rather than 100 billion. Okay? The cell membrane acts as the guardian of the cell. Another previous board exam question that will divide the entire body into 2 compartments, your ECF compartment and your ICF compartment. Okay? That cell membrane is a lipid bilayer. Yan yung classic na description niya. It's a lipid bilayer made up of an outer leaflet. So in this case, ito yung outer leaflet mo, directed against your ECF. And an inner leaflet, directed against your ICF. You've heard of these terms before. Those leaflets are made up of hydrophilic heads. Ito yon. Okay, hydrophilic heads. Okay. And hydrophobic tails. So the hydrophilic heads are directed against the ECF and ICF, while the hydrophobic tails are directed inward. Okay? What will make up those cell membrane? That cell membrane, 55% of it is proteins. So majority of your cell membrane is proteins. What's more important is what won't you find in that lipid bilayer? What won't you find in the cell membrane? You won't find any water. So walang water dyan sa lipid bilayer mo, sa cell membrane. Meron niyang aquaporins, which are basically water channels that can allow water to pass through, but the structure itself, the cell membrane itself, does not have water. Okay? The most important component, meanwhile, of your cell membrane is this one, your cholesterol. That is the most important because it's the one that confers membrane fluidity and permeability. Okay? It's the one that determines membrane fluidity and permeability. Ano ibig sabihin nun, Doc? Siya yung reason kung bakit lipid-soluble ang cell membrane mo. While lipid-soluble substances will have an easier time entering or exiting the cell, it will just go according to concentration gradient. Kung saan mas madami, pupunta sa mas konti. And why water-soluble substances will have a more difficult time penetrating the cell membrane. Why they have to use transport mechanisms to travel across the cell membrane. So it's the cholesterol which determines that. Previous board exam question, what are the factors that determine permeability of the cell membrane? There are several ways to answer this. Mamaya papakita ko sa inyo may equation that deals also with permeability of the cell membrane. Okay, but in that particular question, previous med boards question, okay, the factors that determine permeability of the cell membrane will include temperature, the types of solute present, and the level of cell hydration. Higher temp, more permeable. More lipid-soluble, more permeable. Level of cell hydration also has an impact in terms of movement of certain solutes. So, it will also determine permeability. Okay? Your cell membrane is studded. Okay? So, ibig sabihin may mga naka-insert na two types of proteins. Integral proteins and peripheral proteins. Integral proteins, they will travel across both leaflets, both inner and outer. So, integral. It's tightly attached, will span the entire cell membrane, outer and inner leaflet. While peripheral proteins, as the name implies, nasa periphery lang sila. Nasa isang leaflet lang, hindi dalawa. And these peripheral proteins are loosely attached to the cell membrane. Okay? You might have heard of the term fluid mosaic model of the cell membrane. Ano ibig sabihin ng fluid mosaic model? At ano yung basis bakit tinawag yan na fluid mosaic? If you look at the cell membrane from afar, you're so small and then this is the cell, okay? That cell membrane, that cell will have a mosaic appearance. Remember yung mga artistic work, mga mosaic patterns? It will have a mosaic appearance because these peripheral proteins, okay, are loosely attached and moving around like leaves or flowers on top of a pond moves around. Okay? So it will now give your cell membrane a mosaic appearance when viewed from afar. So, integral proteins, peripheral proteins. Pamboards, Doc. Those integral proteins, okay, they usually function as carrier proteins. Integral proteins are usually carrier proteins. They allow substances to be transported across them, like water-soluble substances, electrolytes, or water. Aquaporin, for example, is an integral protein that will carry water across it. Okay, it's the one involved in osmosis. Okay, ion channels like sodium, potassium, chloride, okay, calcium will allow electrolytes to travel via these integral proteins. You have your GLUT transporters, ATP-dependent transporters. So all of those are integral proteins. When you hear the term integral proteins, you think of proteins that are tightly attached to the cell membrane and will span the entire cell membrane, both outer and inner leaflets. Next. So, different substances will move across the cell membrane differently. Ang tubig, it will travel across the cell membrane via osmosis. So, ito yung ano ko guys, ang simple diffusion for solutes. Ang osmosis, pang water. Do not ever say that water is transported via simple diffusion. No, it's not. Okay? It's water that undergoes osmosis. Okay? It will utilize aquaporins to do that. Aquaporins, okay, are also called Okay, water bridges. In physiology, they like using synonyms. Okay, in your med boards, they may sometimes use terms that you're unfamiliar with. So when I emphasize the synonyms, take note. So water bridges, aquaporins, that's where osmosis occurs with water. Lipid-soluble substances, they're the ones that will undergo simple diffusion. Ano ba yung mga lipid-soluble substances, Doc? Um, this will include gases, oxygen, carbon dioxide, nitrogen, anesthetic gases, um, those also steroid hormones. Those are lipid-soluble substances. They will travel via simple diffusion, meaning across the membrane, they will move from high concentration to low concentration. They won't use any carrier proteins here. They will merely penetrate the cell membrane and move from high concentration to low. It's not energy requiring, it's passive. Okay, they're utilizing simple diffusion. And finally, okay, water-soluble substances, because they cannot penetrate the cell membrane directly, they will now have to utilize carrier-mediated transport. So carrier-mediated transport, when you hear that term, it means they are using carrier proteins. They are using integral proteins for you to be able to transport substances across the cell membrane. So sometimes the transport of that substances is from high concentration to low. We call that facilitated diffusion. Or more commonly, it's from low concentration to high concentration. So we call that, okay, um, active process. Okay, like your primary active transport and secondary active transport. When you hear the term carrier-mediated transport will have three characteristics that you should remember. SSC. SSC, stereospecificity, saturation, and competition. SSC, the three characteristics of carrier-mediated transport. Stereospecificity, saturation, competition. Stereospecificity refers to shape. Stereospecific. Like for example, okay, L-glucose and D-glucose have the same chemical formula. Glucose yan eh. So parehas lang yan na carbohydrate. Okay? However, they have different shapes. Ang rule dito sa mga integral proteins na to, they will only allow, okay, specific shapes to bind with them, to utilize them. Okay? So, in carrier-mediated transport, one characteristic is you need to have the correct shape in order to be transported. They are stereospecific. Next is saturation. Ano ibig sabihin nun? In a given cell membrane, you have finite number of transporters. Hindi yan infinite. So dahil finite yung number niyan, it means your solutes will be transported across these carrier proteins. Okay? With the implication na pag napuno na yan, yung mga carrier proteins mo, yung speed of transport mo will plateau. So you're going to experience what we call Tmax, transport maximum. So this has something to do with a concept called saturation. Okay? Para siyang passenger capacity ng jeepney, passenger capacity ng bus. May limited seating capacity lang yan. Such that ngayon, halimbawa, ang passenger capacity ng jeep mo, 10. Ang nakapila dyan, 30. Kahit 30 yung nakapila dyan, okay, ang pag-transport mo, ang rate of transport mo will be 10 people at a time. So that has something to do with the fact that finite yung number of carrier proteins or integral proteins. So that is saturation. And finally, the concept of competition. Two or more different solutes may compete for the same carrier proteins. So para kang remember that game called Trip to Jerusalem. For example, you have two people, one chair. So they will compete for that chair. Ang pang-boards dyan sa concept ng competition is that you need to remember how do you beat the competition? How do you ensure that if you're the solute, you'll be the one that's going to be able to utilize the carrier protein, the integral protein? Well, basically, you have to have a larger concentration. Ang dalawang taong nagko-compete for us sa isang upuan sa Trip to Jerusalem, ang nangyayari doon is kung malaki yung isang tao, alam super big na guy, and then yung isa super liit na girl, obviously, the one who will be able to sit in the chair is probably the bigger guy. So in terms of solutes, if you have two different solutes, competing for the same carrier, the way for one solute to go through that carrier transport, that carrier protein, is to have a larger concentration. Okay? So that's it for the movement of substances across the cell membrane. Now let's talk about intercellular structures across the cell membrane. So you have cells, okay? And then between the cells, we have these four intercellular structures, one by one. First is the macula adherens, also called your desmosomes. When you hear that term, macula adherens, nag-a-adhere. They cause cells to adhere to one another, bind to one another, attach to one another. So macula adherens is for tight intercellular adhesions. I want you to think of them as like stapler wires. They hold things together the same way that staplers will hold things together. Okay? So you can find this, for example, in your skin. Your epithelial cells, the skin, okay, is waterproof. Ang balat nyo, bakit nagiging waterproof? Bakit pag nabasa, bakit yung water hindi diretso pumupunta sa soft tissues nyo? Your skin is waterproof. The reason for that is the macula adherens or desmosomes. The skin cells are held together so tight, okay, by these macula adherens or desmosomes, that they prevent water from seeping through. Okay, so that is your tight junction. That is your macula adherens. Okay, allowing them to bind with one another, okay, easily. Okay, zonula occludens, hindi masyadong relevant for the exam. Equivalent structure in cardiomyocytes is fascia adherens. It is ring-shaped, increases the surface area for contact. Sa apat na to, kung houses to ng Harry Potter, si Zonula adherens, parang siyang Hufflepuff. Hindi masyadong pinapansin. Hindi siya kasing astig ng Slytherin, hindi siya kastig ng Gryffindor. Number 3, zonula occludens are tight junctions. Zonula occludens tight junctions were misnamed. Why did I say they were misnamed? Because there are actually two types of tight junctions. You have the leaky tight junction, and you have the really tight junction. When you say leaky tight junction, it will allow some substances to move across it. So, leaky. Pag really tight junction, hindi ka agad nakaka-penetrate, nakaka-move across yung substance. So, example of a leaky tight junction, you have your proximal convoluted tubule and the jejunum. Okay? Example of tight junction. The best example there will be your blood-brain barrier. So, this is your collecting duct. Okay, terminal colon, blood-brain barrier. PCT is proximal convoluted tubule. Okay? So, it was misnamed because may leaky tight junction. Now, highlight this. Transcellular, paracellular. Transcellular transport is moving across apical and basolateral sides. What's that, Doc? Okay? Let's take a look at your tight junctions. Where is it located? Take a look. This is your tight junction. If you will notice, your tight junction is located here. It's not at the center. Wala siya dito. Nandito siya near the top. Your tight junctions now will divide the cell membrane into two portions. Your apical membrane and your basolateral membrane. When you hear that term, basolateral membrane, whether in a handout, in a textbook, whether you hear it during residency in one of the conferences, okay, when you hear that term, basolateral membrane, there is only one implication. May tight junction sa lugar na yon. Because only tight junctions are able to do that because of their locations. Tight junctions are located near the top rather than the center. They divide cell membranes into apical and basolateral sites. Similar to yung mga plastic holders ng mga Coke in cans or soft drinks na nakakan, it's near the top rather the center. Ganon ang tight junctions mo. Okay? So, transcellular is movement across apical and basolateral side. So, paganyan at paganyan. Apical to basolateral or vice versa. Travel across the tight junctions is meanwhile, we call it paracellular. So, transcellular, and then ito, paracellular. Okay? Movement across tight junctions. Okay? And finally, the most board relevant, easily the most asked among all of these four in the med boards, gap junctions. When you hear the term gap junctions, I want you to think of rapid intercellular communication. Mabilis na chismisan across the cells. Ano po yung message na tinatransmit, kino-communicate across the cell? Isa lang, isang message lang. That message is this: pare, mag-contract na tayo. So, ang gap junctions mo, makikita mo yan, dalawang sites lang. Cardiac muscles, whether atrial or ventricular, and unitary smooth muscles. Okay? That gap junctions will allow transmission of a message na pare, mag-contract na tayo across these muscles. So what will happen? The signal, the message is transmitted so fast across these gap junctions that basically the cardiac muscles will contract together as one. Pag nagchismisa ng mga tao, ang mga muscles mo, uy pare, mag-contract na tayo, uy pare, mag-contract na tayo, uy pare, mag-contract na tayo. Lahat yan magko-contract almost at the same time. So it's going to be very fast. Okay? Your gap junctions will now precipitate a concept called syncytium. Syncytium is the ability of muscles to contract together as one. So you will hear the term like atrial syncytium, ventricular syncytium, unitary smooth muscle syncytium. So when you have syncytium, that's because of gap junctions, it's because of rapid communication of that single message. Pare, mag-contract na tayo. Okay? Previous board exam question, what are the functional units of your gap junction? So that is your connexon. And this connexon, what is it made up of? Connexin. Okay? In March 2023, they asked a tricky question. What are hexagonal shape structures responsible for intercellular communication? So the choices they gave were actually gap junctions, connexons, some other choices. So it became very confusing for the students because when I taught them, okay, gap junctions, that's the one for rapid intercellular communication. Connexon, that's the subunit of the gap junction. But that was the question given. Hexagonal shape structures responsible for intercellular communication. So the correct answer to this one is connexon. Because the one with the actual hexagonal shape is the connexon rather than the gap junctions directly. So connexon now will be the answer to that question. Another previous board exam question that they have procured from Physio BRS. Low resistance pathway between myocardial cells that allow for the spread of gap junctions that allow for the spread of action potentials are your gap junctions. Now take a look at the nomenclature that I've added in your handout. Okay? Usually dito wala, no? Pero in the most of the questions, I added, may numbers kayo makikita, halimbawa 2-1 dyan. It means nasa chapter 2, siya yung question 1 ng chapter 2, end of the chapter question. So that's the nomenclature na nandoon sa mga Physio BRS questions. I've added those Physio BRS questions basically, okay, because they're either getting it from Physio BRS, modifying it, or kahit hindi lumabas yung questions na yun sa board exams, guys, maganda siyang way to test you. Maganda siyang practice test question, yung Physio BRS na yan. Do I recommend that for students to still read Physio BRS for their exams, for the med boards? Honestly, at this point, after internship, no more. Concentrate doon sa main handout na lang ng top-notch. I've gotten the best of Physio BRS and the other resources. Okay? Diyan na. Makakapag-survive na kayo. Makinig kayo sa lecture. Okay? Occasionally, you watch the QR codes. Okay? Para doon sa mga lecturettes ko. And you're good to go. With the pearls, with the buzzwords, and with the flashcards, you'll be prepared as best as possible na talaga for the med boards. It won't be perfect. There will definitely still be a lot of questions that we won't be able to cover. Medicine is really that large. Okay, even if you have very good teachers, very good handouts, very good system, you'll still be guessing and you'll still be using what you've learned from med school for the med boards. But you'll have a good chance. And more importantly, you would have learned what you're supposed to really learn to become good physicians with us. Okay? So concentrate dito sa main handout. We've discussed so far intercellular structures. Again, macula adherence, think of what? Stapler wires, right? Think of your skin for tight attachments. Zonular adherence, Hufflepuff. Masyadong pinapansin. Zonular occludence or tight junctions. Okay? Leaky tight junction is PCT. Tight junction is the blood-brain barrier. Okay? Two types of transport. Across the tight junction, we have paracellular transport. Okay? Across apical and basolateral sides, we have transcellular transport. And the most more relevant, gap junctions. Okay? Responsible for syncytium, muscles contracting together as one. Seen in cardiac and unitary smooth muscles. So it's seen in both atrium, ventricles, unitary smooth muscles. Functional unit is connexon, hexagonal shape. Okay? And subunit of connexon, connexin. Transport now across the cell membrane. We have non-carrier mediated transport, so hindi gagamit ng carrier proteins. And carrier mediated transport, gagamit ng carrier proteins or integral proteins. So the non-carrier transport across the cell membrane, okay, we have your simple diffusion, endo, and exocytosis. Simple diffusion, you're going to move substances from high concentration to low, okay? This is going to be considered, these are the terms that we like to use, passive downhill. When you use that term, it means you're moving from high concentration to low concentration. You're not utilizing energy because you're doing a natural process. Parang gravity assisted. Parang nag-move ng ball from the top of the hill to below the hill. Okay? So simple diffusion is used by gases, okay, by alcohol, and by steroid hormones. Steroid hormones will include aldosterone, cortisol, sex hormones. Okay, testosterone, estrogen, progesterone. Endocytosis. Ano ibig sabihin, Doc, ng endocytosis? Sa endocytosis, kung ito yung cell membrane mo, basically, the cell membrane will pinch inward. And in the process of pinching inward, it will form a vesicle na papasok na lang dun sa loob ng cell. So we have terms here like pino and phagocytosis, cellular drinking, cellular eating. Cellular drinking for smaller substances, cellular eating for larger substances, phagocytosis. So endocytosis, you have the cell membrane pinching inward. The opposite is exocytosis, wherein the cell membrane will pinch outward. So when the cell membrane, itong membrane na to nagpinch outward to release the contents, okay? This is exocytosis. So this is done by hormones and neurotransmitters. So hormones and neurotransmitters are the ones who will do that. So non-carrier mediated transport. Simple, endo, exocytosis. Next is carrier mediated transport. Osmosis is the transport of water from low concentration to high concentration. Now, makinig pag sinabi mo kasing from low concentration to high concentration, it means you're moving substances from dilute to concentrated. Na kung tutusin mo, looking at it from another's perspective, it's basically kung saan madami ang water in comparison to the solute, and it's going to move now to an area na mas konti ang water in comparison to that solute. So, basically, water is still moving from high concentration of water to low concentration of water. But since ang concentration natin, we usually define it as concentration ng solutes, hindi ng tubig. Tubig is supposed to be a solvent. That's why you're going to hear the term osmosis is moving of water from low concentration to high concentration. Let's make this simpler. From dilute, it's going to move to the area that is more concentrated. Malabnaw to malapot. Okay? Next, facilitated diffusion. Facilitated diffusion, you're moving substances from, okay, high concentration to low. But the difference from simple diffusion is that you're going to use a carrier protein, an integral protein. Okay? So the ones who will use this facilitated diffusion are mainly your GLUT transporters. Okay? What are those GLUT transporters, Doc? Okay? That's your GLUT 1 to 5. So GLUT 1, 2, 3, 4, 5. Let me give you some mnemonics. Because the one that they like to ask in physio and biochem is what is the location of these GLUT transporters. So where do you find these GLUT transporters? GLUT1 and GLUT3 are found in the brain and RBC. GLUT1 and GLUT3 are found in the brain and RBC. To be more specific, in the brain, GLUT1, you're going to see this in your blood-brain barrier. GLUT3, that's the one that you will see naman in your neurons. Previous board exam question. How do you remember that, Doc? Well, yung 1, mukha siyang barrier. So, siya yung blood-brain barrier. Yung 3, basta hindi siya mukhang barrier, so siya yung neurons. Wala tayong mnemonic dyan, guys. Hardcore, ano lang yan. So, 1 yung barrier, okay? 3 yung hindi barrier, so siya yung neuron, siya yung natira. Okay? GLUT2, where will I find GLUT2? GLUT2, I'm going to find in my liver and pancreas. GLUT4, I will find in my muscles and adipose. And finally, GLUT5, I'm going to find in my small intestines for the transport of fructose. Okay? Mnemonics. Touch your head. This is GLUT1 and GLUT3. Okay? Brain. Okay? RBC. Touch your heart. Touch your tummy. Okay? This is GLUT2. 1 and 3, and then tummy, this is GLUT2. This is your liver and pancreas. GLUT4, touch your butt. Okay? In your butt, you're going to feel muscles and adipose. Touch your head, 1 and 3. Touch your tummy, GLUT2. Okay, touch your butt. Okay, that's your GLUT4, muscles and adipose. GLUT5 is small intestines transport of fructose. Remember this 5-letter word, fruit. F-R-U-I-T. GLUT5, your fructose is being transported there. Okay? So let's go back. So facilitated diffusion is GLUT transporters. You're going to move substances again from high concentration to low, similar to simple diffusion. But you're going to utilize carrier proteins. Okay? When you hear the term active transport, it means you're moving substances from low concentration to high concentration. Moving substances from low to high concentration is unnatural. It's like moving people na marami na halimbawa sa isang kwarto, tapos magpapapasok ka pa. So, when you move things from low concentration to high concentration, you're going against the natural order of things. That's why we tend to use the term pag active transport, we use the term uphill. It means you're parang you're going against gravity when you do that, when you move substances from low concentration to high. Active transport will therefore require energy, the same way that it's harder to move things uphill, that it will require energy to move things uphill. So active transport, when you move substances from low concentration to high, you're going to require energy. Now, eto yung rule. Ano difference, Doc, ng primary and secondary? Pag primary active transport, the source of energy is ATP. The breakdown specifically of ATP into adenosine diphosphate. Pag secondary active transport, the source of energy is the sodium gradient. Anong ibig sabihin noon? Okay? You're going to utilize the movement of sodium from high concentration to low concentration. And doon tayo makikisabay. Okay? To move a substance from low concentration to high, low concentration to high. Okay? Now, common mistake here, and if you read Physio BRS, sometimes it might mislead you into making that mistake. Common mistake here is to think that the terms co-transport and counter-transport are only seen in secondary active transport. Co-transport is also called symport. Counter-transport is also called antiport or exchange. Okay? So, common misconception, isip ng mga tao, okay, dito lang yan nakikita sa secondary active transport. No, that's not true. Okay? Co-transport and counter-transport are generic terms. You can also see that in primary active transport. So, for example, the sodium-potassium ATPase pump, in which you have 3 sodium, okay? You have 3 sodium going out, 2 units of potassium going in with the use of ATP is considered a counter-transport because you have sodium and potassium moving in opposite directions. Okay? So, co-transport and counter-transport are terms not specific to secondary active transport. You can also see that in primary active transport. Okay, now, Doc, bakit ito yung primary? Bakit ito yung secondary? Bakit kapag gumamit ka ng ATP, okay, bakit ikaw yung primary? Bakit hindi ka tinawag na secondary kung ikaw yung gumamit ng ATP? The reason for that is this one. The sodium-potassium ATPase pump, if you will remember your med school, basic, your first year, it's the one that will keep sodium away from the cell, out of the cell. 3 sodium out, 2 potassium in. It's the one that keeps sodium out of the cell. Guys, it's the one that creates that sodium gradient. Sodium, okay, gradient means there's a difference between two compartments. The reason why you have that sodium gradient in the first place is because of the sodium-potassium ATPase pump. Ergo, lahat ng secondary active transport mo, ultimately, nagre-rely dyan sa sodium-potassium ATPase pump. Kaya siya tinawag na secondary active transport. May sodium gradient ka, that sodium gradient, magpasalamat ka kay sodium-potassium ATPase pump. Siya yung gumawa. Okay? So, anong implication nito, Doc? Pag tumirik ang sodium-potassium ATPase pump, titirik din ang mga secondary active transport mo. Lahat. Because they rely on the sodium gradient created by the sodium-potassium ATPase pump. You must have heard of digoxin. Digoxin is a sodium-potassium ATPase pump inhibitor of the heart muscle. It will inhibit just some of the sodium-potassium ATPase pump. You can't inhibit all. The patient will die if you inhibit all the sodium-potassium ATPase pump. But because you inhibit the sodium-potassium ATPase pump with the use of digoxin, at least some of them, okay, hindi gagana yung mga secondary active transport mechanism sa heart. One of those secondary active transport mechanisms sa heart is the calcium exchanger. That sodium calcium exchanger in the cardiac muscle will cause calcium to move out of the cardiac muscle and into the blood. So, ano implication nito if you use digoxin? If you use digoxin now, okay, hindi gagana yung sodium-potassium ATPase pump, hindi gagana yung sodium-calcium pump. More calcium will remain inside the cardiac muscles. And when more calcium remains in the cardiac muscles, it provide you with a greater force of cardiac contraction. Remember, okay, this is my personal saying. I've been teaching this to my students even long ago. Calcium is to muscle what spinach is to Popeye. Calcium is to muscle what spinach is to Popeye. It provides you with power. Okay? I hope kilala nyo pa, guys. Si Popeye, okay? Kinabahan ako, baka di nyo nakilala. Who's Popeye? So, calcium is to muscle what spinach is to Popeye. It provides you with power. So, more calcium means more power. Use digoxin. Okay? It will now give you greater ventricular contractility, which is useful if you have heart failure. Okay? You can use now digoxin so that ma-counteract mo yung heart failure mo. Okay? So, primary, secondary, active transport. Primary, ATP ang source of energy. Secondary, sodium gradient ang source of energy. Co-transport, counter-transport. Okay? Anong tawag dito? It's generic. It's not specific to secondary active transport. Now, yung iba nalilito doon sa mga secondary active transport na co-transport, counter-transport. Kasi sabihin ko sa kanila, sodium will move downhill while the other substance transported in a secondary active transport is moved uphill. And I will say to them, this can either be co-transport or counter-transport. So, nalilito yung ibang estudyante kung anong ibig kong sabihin dito. Ganito yun, ha? Sodium will, in the secondary active transport, will always move from high concentration to low concentration. Okay? Ngayon, valid yung pwede kang mag-move ng substances in the same direction, or opposite direction, counter-transport, even though one is downhill and the other is uphill. What do I mean by that? Okay? Bakit naging pwedeng for co-transport, counter-transport? Substance X, you're going to move from small to large. So, sodium X exchanger. Okay, this is now co-transport. Okay? Sodium, for example, you can move it, okay, to transport a substance from low concentration again to high concentration. But this time, in an opposite direction to that sodium. So this one, the sodium Y transporter, is actually a counter transport. Okay? So the terms downhill and uphill, I think kaya nalilito yung mga estudyante. Iniisip nila direction eh. Doc, kung downhill ako, dapat pa ganyan. Kung uphill ako, dapat pa ganyan. No! Okay, the terms downhill and uphill merely means you're moving a substance from, okay, downhill is from high concentration to low, malaki to maliit. Okay? Uphill means you're moving substances from low concentration to high. Uphill does not mean moving to the right or left. It just means moving from low concentration to high concentration. So, ingat ha, kasi may questions sa Fisher BRS na nandiyan sa main handout na nakita ko doon nalilito yung mga estudyante. So, I have to utilize this drawing and explain it again. If you're still having difficulty, hindi pa rin magets, okay lang yan. You message me on Facebook and only on Facebook Messenger, please. Pakilala po kayo matino. State your full name, your med school, okay, your top-notch number, okay? And then you ask your questions. If you want something repeated by me, Doc, di ko talaga maintindihan po ito. Pwedeng pa-repeat, pwede pong pa-explain. I'll gladly call, make the drawings, explain it to you. Sulitin natin bayad ng mga magulang nyo. Try to learn, work with your teachers, work with your MGs and mentors. Nandito na rin kayo sa top-notch, sulitin nyo na, enjoy the process. Treat your teachers, MGs, mentors with respect. Doktor lahat yan. Okay, na gustong tumulong sa inyo talaga. Okay, to the best of their abilities. So, let's promote a positive learning environment for everyone. Not just for the students, but also for your teachers, MGs, mentors. Okay? So, carrier-mediated transport, osmosis for water, okay? Facilitated diffusion for think of glute transporters. You're moving substances from high concentration to low, okay? With the use of carrier proteins. Active transport means you're moving substances from low concentration to high. For that to happen, you're either going to use ATP as source of energy or sodium gradient. If you use ATP as source of energy, that's primary active. If you use sodium gradient as source of energy, that's secondary active transport. Examples of primary active transport, we have the very famous sodium-potassium ATPase pump. Mnemonic for that is 3 na token. 3 sodium out, 2 potassium in. 3 na token. Okay? The sodium-potassium ATPase pump. Okay, so you have in the sodium-potassium ATPase pump, you have 3 sodium going out for every 2 potassium going in. Okay? What's the reason for this? Why do you have a sodium-potassium ATPase pump that's ubiquitous, present in almost all of the cells of the body? I always tell my students, God is the greatest engineer of them all. And the best evidence for that is the human body. Everything was engineered to perfection. And everything had an engineering reason. So, think about this. If God is indeed the greatest engineer of them all, why did He give almost all of your cells the sodium-potassium ATPase pump? Several reasons. The main reason is actually to keep sodium out of the cell. To ensure that sodium remains out of the cell. In the process kasi, for example, of depolarization and action potential, sodium will go into the cell. And if you will remember the classic dictum that everyone in med remembers, where sodium goes, water follows. Where sodium goes, water follows. So, what if hindi ka love ni... Halimbawa, let's pick halimbawa si Prince Rubio. Halimbawa si Prince Rubio, pinagtripan ni God, sabi, hindi ko masyadong feel tong si Prince, pagtripan natin. So, wag natin siyang bigyan ng sodium-potassium ATPase pump. What will happen to Prince pag wala siyang sodium-potassium ATPase pump? In the process of depolarization, sodium will remain inside the cell, nothing to get it out of the cell. So remember that dictum, where sodium goes, water follows. So when water follows here, if all of your sodium potassium ATPase pump are not working, you're going to have cellular swelling and then eventually cellular lysis. That's why you need a sodium potassium ATPase pump. That's why you were engineered to have the sodium potassium ATPase pump in almost all of your cells to keep sodium out of the cell so that you won't have cellular rupture. That sodium potassium ATPase pump will also participate in your basal metabolic rate because almost all the cells have it. Therefore, ang dami niyan, ang daming ATP kailangan gamitin per day. So it will now contribute to your basal metabolic rate. And your sodium potassium ATPase pump, its final use, more relevant, is that it will contribute to your resting membrane potential. When you hear the term RMP, resting membrane potential, okay, wag masindak. Basically, ang ibig lang sabihin yan, for all intents and purposes, it's your intracellular charge. The normal RMP for a large neuron is negative 70 millivolts. So deep inside our cells, it's always negative. All the cells of the body is negatively charged in comparison to the outside of the cell. Okay? It just the value varies. Like for example, in a neuron, it's negative 70 millivolts. In a cardiac muscle, it's negative 90 millivolts. But all cells negative yan inside. So if RMP is the intracellular charge, okay, one of the things that contributes to the negative charge is your sodium potassium ATPase pump. Kung negative 70 millivolts ang RMP mo, ang kinocontribute ng sodium potassium ATPase pump is negative 4 millivolts out of the negative 70. Paano siya, Doc, nag-contribute noon? Dahil for every 3 positive ions going out of the cell, only 2 positive ions are entering the cell. 3 sodium out, 2 potassium in. Therefore, the inside of the cell, in comparison to the outside, dahil 3 labas, 2 pasok, the inside of the cell in comparison to the outside is negative. So in that case, it will contribute negative 4 out of the negative 70 millivolts. Other notable primary active transporters relevant to your board exam is your hydrogen potassium ATPase pump, okay, of the parietal cells of the stomach. So go back to super basic. This is the parietal cell of your stomach. This is the lumen. And this is the blood. How do you actually secrete hydrochloric acid into your lumen or into your gastric lumen? Must know. Okay? Very simple. Okay? Carbon dioxide plus water through the use of carbonic anhydrase enzyme, carbonic anhydrase, will first give you carbonic acid, okay, which will then freely dissociate, meaning it won't use any enzyme, freely dissociate into H plus and bicarbonate. This bicarbonate will then go into your blood in exchange for chloride. Okay, it will go to your blood in exchange for chloride. Okay, so this happens in the parietal cell of your stomach. Okay, at this point, that chloride, that H plus that you produce here, it will go to the gastric lumen in exchange for potassium. This is an active process that will require ATP. Okay, so what will happen? The H plus will find itself in the gastric lumen. What will happen to this chloride? The chloride will then be secreted, okay, also into the gastric lumen, forming, okay, hydrochloric acid at the end of the day. Okay, this one, the hydrogen potassium ATPase pump, or to be more specific, the hydrogen potassium ATPase exchange pump. Okay, it is known by another name. The other name for the hydrogen potassium ATPase pump, this is what we call your proton pump. Aha moment! Doc, yan yung ini-inhibit ng mga omeprazole, pantoprazole? Yes. Your proton pump inhibitor will actually inhibit the hydrogen potassium ATPase exchange pump. Eventually, this hydrochloric acid will find itself in the small intestines, in the duodenum, for example. So, ang gimmick ng katawan natin, yung bicarbonate na nasecrete sa blood, eventually, that will find its way into the small intestines via the, anong tawag dito? Via secretions, okay, ng duodenum, okay, initiated by hormones like secretin, okay, and also through the Brunner's gland secretion, that bicarbonate from the that's secreted into the blood in exchange for chloride, okay, will find itself, okay, back into the lumen of your small intestines. Anong silbi, Doc, ng bicarbonate ngayon? That bicarbonate plus the hydrochloric acid, okay, will then form eventually your water and carbon dioxide along with the chloride na libre. Okay? So, it's a way, this bicarbonate, we're going to use it to neutralize the hydrochloric acid once it enters the duodenum. Okay? So, dito, hydrogen, potassium, ATPase exchange pump. Okay? There are other pumps, but the most more relevant we've just discussed. Secondary active transport. Okay. More relevant. SGLT1, SGLT2. Sodium glucose co-transport type 1, sodium glucose co-transport type 2. You will transport using this SGLT either glucose or galactose. SGLT1, SGLT2. Ang tinatanong sa exam is, are there locations? How will you remember that SGLT1 is in the SI, small intestines, SGLT2 is in the kidneys, in the PCT to be more specific. Remember, mnemonic, you have one small intestines, but you have two kidneys. SGLT1, small intestines. SGLT2, two kidneys. Okay? So, they are used to transport glucose and galactose across them. Next is the sodium potassium 2-chloride symport found in your thick ascending limb loop of Henle. Okay? The sodium potassium 2-chloride symport in the tal of LH is important because this is the one inhibited by your loop diuretics, by your furosemide. Okay? What is the brand name for furosemide? Lasix. Lasix. Why did we call it Lasix? Nice to know, trivial. Because it lasts 6 hours. Its half-life is 6 hours. 6 hours. That's why it was called Lasix. Okay, nice to know. So, we've just discussed, okay, examples of primary and secondary active transport. More relevant, again, sodium potassium ATPase pump. Function of the sodium potassium ATPase pump, keep sodium out, participates in basal metabolic rate, participates in your resting membrane potential, your intracellular charge. Hydrogen potassium ATPase pump of the stomach, also called your proton pump, the one inhibited by PPIs like omeprazole, pantoprazole. Okay? Next, secondary active transport. Where do you find SGLT1? In the small intestines. Where do you find SGLT2? In the kidneys. One intestines, two kidneys. And the sodium potassium 2-chloride symport, what diuretic will inhibit that? Your loop diuretics. For example, your furosemide, also called your Lasix. Okay? Next. When we place equations in your handout, it means it's important. It means it's been asked before. There are a lot of physio equations. If you look at Guyton, you look at Byrne, we didn't place all of them in your handout. Okay? So, pag nakalagay dyan sa handout ninyo, it means natanong na yan before. So, all the equations in your handout, okay, they can be asked again. Some batches, ang dami-daming equations. Some batches, wala. But it's better to be prepared for a batch na boards na maraming physio equations. We created a poster for the physio equations. Print that poster in one long bond paper. Place it doon sa study wall ninyo. Okay? So one of the equations being utilized before is the formula for simple diffusion. So we have here simple diffusion, flux, or J is basically simple diffusion or flux, is equal to permeability times the surface area A times the concentration gradient or concentration difference C1 and C2. So implication of this formula, if J is simple diffusion, the flux, the rate of simple diffusion, the more permeable you are, the faster the rate of simple diffusion. The higher the surface area A, the faster the rate of simple diffusion. And the greater the concentration difference across two compartments, the greater the rate of simple diffusion. Previous board exam question related to my first few slides mentioned earlier. Permeability in this formula will be increased by the following. One is oil-water partition coefficient of the solute. Ano, what's that, Doc? That oil-water partition coefficient? Basically, that's how lipid soluble you are. Oil-water partition coefficient, think of it as lipid solubility. So the more lipid soluble you are, the more permeable the membrane to you. The more permeable, the faster the rate of simple diffusion. Second is decreased radius of the solute. The smaller the solute, the more permeable, the faster the rate of simple diffusion. And finally, okay, affecting permeability based on this formula is decreased membrane thickness. The thinner the membrane, the more permeable. Makes sense. Manipis yung barrier, mas makaka-penetrate yung mga substances mo. So, the P in this formula, okay, previous board exam question, oil-water partition coefficient, a fancy way of saying lipid solubility, okay, radius of the solute, membrane thickness. Next, carrier-mediated transport. Again, we mentioned this before, SSC, stere specificity, saturation, and competition. Two or more substances may have the same chemical formula, but if they have different shapes, D-glucose, L-glucose, only one of them will be able to penetrate and utilize the carrier protein. Saturation, okay, finite, once again, a number of carriers. So after you reach saturation, you're going to reach also what we call transport maximum. Think of it as the speed limit of transport. Okay? Nagkakaroon ka ng speed limit kapag puno ng salop, kapag saturated na yung mga carrier proteins mo in the cell membrane. And then we have competition. Again, two or more different substances may compete for the same transporter. SSC, stere specificity, saturation, competition, are only seen once again in carrier-mediated transport. Panglito namin sa mga estudyante dyan, simple diffusion, walang SSC. Okay? Endocytosis, exocytosis, walang SSC. Nakikita lang yan sa facilitated diffusion, primary and secondary active transport. Now, which is faster? Facilitated diffusion, FD, or simple diffusion, SD? It depends. At low solute concentration, facilitated diffusion is faster. Why? It's carrier-mediated. The analogy here, think of Usain Bolt, a runner. He runs very fast, right? But Usain Bolt will be able to travel faster if Usain Bolt is riding a Ferrari, if he's using a carrier. So you may be moving from high concentration to low, okay? But if you're using a carrier, it's like riding you're already being transported very fast, but you ride a Ferrari, use a carrier, it's going to be much faster. So at low solute concentration, facilitated diffusion is faster. But at high solute concentration, simple diffusion is now faster than facilitated. Why? Facilitated diffusion has a speed limit because of the concept called saturation. Simple diffusion has no speed limit. It has no saturation. So, sky is the langit pagdating sa sky is the limit pagdating sa simple diffusion. Okay? So, GLUT 1, 2, 3, 4, 5, we mentioned earlier. Board relevant also. If GLUT 1 and 3 are found in the brain RBC, if GLUT 2 is liver and pancreas, GLUT 4 muscles, adipose, GLUT 5 SI for fructose. Among all of those, okay, only GLUT 4 is insulin dependent. Okay, it's activated with the use of insulin. Everything else is non-insulin requiring. And that is good. Okay? Why is that good? Because if, for example, GLUT 1 and GLUT 3, okay, will require insulin, kawawa lahat ng mga DM type 1. Mati-deads na lahat yan. Dahil hindi gagana yung GLUT 1 and 3 nila if insulin dependent yan. So among all the four, only GLUT4 is insulin dependent. A previous board exam question. Okay? Sodium potassium ATPase pump, we have discussed this, okay, previously. Trina token contributes to RMP, contributes to your BMR. Okay? Next, secondary active transport, na-mention na rin natin. Again, wag magpapalito The terms co-transport and counter-transport is not specific to secondary. It can also be seen in primary active transport. Okay? Osmolarity, osmotic pressure, effective osmotic pressure. Okay, makinig na. Even for my lecture, in the next few hours, I'm going to discuss osmolarity that will make you think it's synonymous with the term concentration. Okay? Mas madali lang Mas madali lang explain pag osmolarity is equal to concentration. Mas madali for the students to understand, mas madali for the teacher to teach. However, I'm telling you that's not technically true because osmolarity is not just concentration, it's actually concentration times the number of dissociable particles. Okay? What do I mean? For example, if I tell you that there are two compartments here, okay, one of them will contain 300 milliosmoles of glucose and 300 milliosmoles of glucose. So, in this case, okay, you will be able to say na, okay, they have the same osmolarity, doc. Okay, walang problema yan. However, okay, what if, okay, I have two solutions na ang concentration nila 300 milliosmoles of sodium chloride and then ito 300 milliosmoles of glucose pa din. Sorry. Dahil pala ito na lang ginamit ko example. Okay? 300 osmoles per liter na sodium chloride, 300 milliosmoles per liter na glucose. Sorry, ito na lang pala dapat example ginamit ko kanina. Okay? You would think na, Doc, pareha silang 300. So, dapat isotonic sila to one another. Okay? No. Okay? Hindi sila same. Hindi sila parehas. They are not isotonic to one another. Why? The sodium and the chloride here can dissociate into sodium ions and chloride ions. The glucose here will not dissociate into gluc and os. Okay, isa lang yan. Glucose lang yan talaga. So, hindi siya dissociable ion. So, actually, when you compare the two, this one will have an osmolarity 2 times higher compared to this one. Okay? Dahil dissociable yung mga ions niya. Okay, so please take note from here on, just for discussion purposes, I'm going to say osmolarity, concentration. You'll think it's almost the same. Okay? But technically, hindi siya parehas kasi you have to take into consideration yung number of dissociable particles. Okay? Now, the normal values will vary according to textbooks or references that you have. I am well aware that when I say the normal ECF and ICF osmolarity is 300 milliosmoles per liter, I'm well aware that not all textbooks will say that. Some will say 285, 290, 295, 310. Well aware of that. Okay? But the values that I'm going to give to you are the values commonly agreed upon by physio teachers in the Philippines. It's only around 150 physiology teachers in the Philippines associated with the society, Philippine Society of Physiology. So more or less, we know, everyone knows everyone pagdating sa physiology. So the values I'm giving to you, we've agreed upon this, okay, informally. So it's 300 milliosmoles per liter. Utilize the values listed in your physio handout. Will they ask this in your exam? Na, Doc, paano kung tanungin kami? 285, 295, 300, 310. Unlikely, Doc, because even the Board of Medicine is aware, even from long time ago, probably pinamanan na nila yan. The values will vary depending on the reference. So when they ask, even if they ask for normal values, trust me, the choices will be so far away na hindi ka masyadong makikita mo na ito na yung closest dun sa alam ko na normal value. Okay? Next, osmotic pressure. I want you to remember that osmotic pressure, eto, is different from effective osmotic pressure. They are not the same. Osmotic pressure and effective osmotic pressure. Osmotic pressure is the number of particles times the concentration times RT, gas constant, absolute temperature. So that's osmotic pressure. Number of particles times the concentration. Okay? Parang dito, no? Parang concentration times number of dissociable particles. Parang ganyan lang din yung osmotic pressure mo. Pag effective osmotic pressure, it's osmotic pressure times a value that we call reflection coefficient. So effective osmotic pressure will take into consideration reflection coefficient. Ito yung wala sa osmotic pressure alone. When you use the terms isotonic, hypertonic, you are referring to effective osmotic pressure. You're taking into consideration reflection coefficient or RC. When you use the term isoosmotic, hypoosmotic, isoosmotic, okay, hypoosmotic, that's just osmotic pressure, not effective. So effective osmotic pressure will take into consideration RC. Okay, and that's the only time that you can properly use the terms isotonic, hypertonic, and hypotonic. So, are you saying, Doc, na kapag isoosmotic, it's not necessarily isotonic? Yes, it's not necessarily the same. Okay? So, pwede kang isoosmotic pero hindi ka isotonic. Okay? Dahil ang mga isotonic, hypotonic, you have to take into consideration reflection coefficient. Okay? What's reflection coefficient, Doc? Reflection coefficient is a number between 0 and 1 that describes the ease by which a solute permeates a membrane. A number between 0 and 1. The extremes, an RC of 0 is seen in urea. An RC of 1 is seen in albumin. Most substances will have an RC between 0 and 1. Ano ibig sabihin yan, Doc? There's a drawing here, a picture here, but I prefer to draw ganito. Albumin has an RC of 1, right? RC is actually a formula. RC is the amount returned over amount sent. Ang ibig sabihin nito, hindi ko na-gets. Halimbawa, meron tayong 4 units ng albumin dito on one side of the cell membrane. Okay, 4 units of albumin. Albumin is negatively charged, size relatively big because it's a protein. So when albumin tries to penetrate the cell membrane, it will bounce back or be reflected. So if you compute ilan yung pinadala mo at ilan yung bumalik or nag-bounce back, let's change this term nga, amount bounce back. Okay, versus amount sent. So amount na nag-bounce back or nag-reflect, amount na nag-return is 4 if you have 4 units here. Amount that you sent is also 4. So 4 over 4 is equal to 1. Albumin has an RC of 1. Albumin, yung letter L, gawin mong 1. So that will be your mnemonic na albumin has an RC of 1. Okay? Sino yung may RC of 0? RC of 0, you see that in your urea. So RC of 0, urea. Let's take a look at what happens to urea, okay? 4 units of urea, as an example, found on one side. This is the cell membrane. If urea tries to penetrate the cell membrane, no problem. It will be able to penetrate the cell membrane without any issue. So what is now the reflection coefficient of urea? So this is the amount returned, amount bounce back, over amount sent. Sorry guys, ang pangit ang sulat ko ha. So the amount returned here is 0 kasi walang nag-bounce back, walang nag-reflect, walang bumalik. Ilan yung pinadala natin? 4. So 0 divided by 4, 0. So RC of 0 is urea. Mnemonic, yung U ng urea, gawin mo in such a way na mukha na siyang 0. Urea. So that will be your mnemonic na RC ng urea is 0. Okay? So, ano implication nito? Again, you go to the extremes. Albumin has been described as an effective osmol, okay, because it will hold water It will attract water because albumin will not penetrate the cell membrane. It's attractive to water. Okay? It's an effective osmol. Urea has been called an ineffective osmol because it cannot hold water. It moves across the compartment until yung urea mo maging equal yung number. In a hospital error, 60-year-old transfused with large volume of solution that causes lysis of her red blood cell. What is the solution most likely given? The normal osmolarity of inside your RBC is 300. So magkakaroon ka ng lysis, okay? Kapag yung osmolarity mo dito sa labas is less than 300. Sabihin mo 100. Yung water ngayon will penetrate the RBC, cause it to lyse. So when will this happen? O, tingnan natin kung kailan nagkakaroon ng concentration difference at kung anong effect. Okay, one by one. Okay? 150 micromoles of sodium chloride. Okay? RBC sa loob 300. Nag-infuse ka, so nilagyan mo yung ano niya, yung ECF plasma niya ng 150 na sodium chloride. Yung 150 na yan magdi-dissociate into sodium and chloride ions. So ang mangyayaring mathematics niyan, 150 times 2, 300. So in this case, okay, walang lysis, isotonic to one another. Yung isa, 300 micromoles of mannitol. Yung mannitol, hindi na magdi-dissociate yan. So kung 300 to, wala ring isotonic din to one another. Pag 350 yung ginamit mong mannitol, water of the inside the RBCs will then go out. Okay, into the outside compartment. So in this case, a third, okay, what you will have here is not lysis but shrinkage ng RBC mo. Okay? Letter E, 150 mole of calcium chloride. So 150 times 3, yung nasa labas mo 450. So again, in that scenario, kung 450 yan sa labas, okay, mag-shrink yung RBC mo. So ang tamang sagot dito is urea. So paisip yung tao, Dok, bakit urea yung tamang sagot dyan? 300 yan. Hindi ba dapat isotonic? No. Okay, because once again, you're taking into consideration here effective osmotic pressure and not just osmotic pressure. You're taking into consideration here RC. What's happening, Doc? Okay? Remember the case. We infuse someone, okay? We infuse someone with a solution, okay, na may 300 microosmoles per liter na urea. So yung urea na yan, na solution, may water yan, tapos may urea. Nilagay mo dito sa patient natin na may plasma sa labas, tapos sa loob, okay, may 300 microosmoles per liter na osmolarity dito sa loob ng RBC. So what will happen? Madadagdagan yung water niya, of course, kasi yung solution mo may tubig yan. Dito, 300 yung dinagdag ko. So, you're going to think na, Doc, isotonic, wala dapat movement, hindi dapat magsishrink, magsiswell yung size ng cell. But you gave them urea. Ang mangyayari sa urea na yan, dahil walang urea sa loob, maraming urea sa labas, urea will move dito sa loob ng cell hanggang magpantay yung urea concentration inside and outside of the cell. So, magiging tong 150 na urea, 150 na urea. So, isipin mo, okay, Doc, kung 150, 150, wala pa din dapat change sa size ng cell ko. Kasi, nalagdagan siya, 150, 150. Kung 300 to, 300 to, okay, nalaglagay ako ng 150, 150, dapat patas lang. Equal lang. Okay? You added a urea solution. Meaning, you added water plus urea. Tumaas yung volume ko, okay, dyan sa plasma. So, yung urea ko, nag-move nga dito hanggang magpantay sila. Number of urea here, number of urea dito sa labas, parehas. But my water remained here sa plasma. So, itong original na 300 osmolarity sa plasma, bababa yan. To sabihin mo kahit 280, 250. Osmosis will now occur until magpantay ang dalawang yan. Sabihin mo maging 290, 290. So, what will happen? Water will enter the RBC and cause swelling and then eventually lysis. This is a very good question. A previous board exam question na kahit ako napaisip, okay, kung ano yung nangyari, kung paano siya magsiswell. So I hope you got it kung bakit siya nag-swell. with 300 micromoles of urea. Okay, you can go back and look at the explanation, chapter 1, question number 9 in your Physio BRS. Physio BRS already has explanations. Pag di nyo na-gets dun sa explanation niya, you message me. I'll gladly explain as best as I can. We're not gods, we're humans. Okay, we don't know everything. But we will definitely do our damn best to help and explain it to you because that's our role as your teachers. Okay? Next, RMP versus AP. Resting membrane potential and action potential. What should you remember? Okay? Resting membrane potential is intracellular charge. It's the charge inside the cell, all intents and purposes. It's exhibited by all cells. Action potential is only seen in excitable cells. So what are those? Neurons and all types of muscles, whether skeletal, cardiac, or smooth. Okay? So ang action potential is an on-off signal that's transmitted or propagated. Doc, di ko na-gets. It's depolarization followed by repolarization that is propagated. Doc, hindi ko na-gets. Action potential is basically electricity. Okay, electricity, you have electrical charge that's transmitted across cells. So, kuryente, action potential, resting membrane potential, intracellular charge. That's the simplest analogy that we can give. Not perfect analogies, but the simplest. Okay? So, the resting membrane potential is caused by the Nernst potential of sodium, potassium, your potassium leak channels, and the sodium-potassium ATPase pump. I've actively avoided the use of and discussion of the Nernst potential in your handout and in my lectures. Why? The Nernst potential, the Nernst equation, you don't need for the boards because anything that will require scientific calculators, lahat ng may log, pi, square root, di yan itatanong sa exam because you are not required to bring scientific calculators in the exam. So if your equations will have square root, log, okay, take comfort in the fact hindi yan tatanong sa exam. So Nernst, wala. However, you do need to learn to remember this, okay? These three, they contribute to the resting membrane potential of negative 70 millivolts in neurons, negative 90 millivolts in cardiac muscles. If you look at the Nernst potential for sodium and potassium, you will see that the Nernst potential for potassium is negative 85 and for sodium is positive 65. Ano implication nito, Doc? Sino ang mas malapit kay negative 70? Si negative 85 o si positive 65? Mas malapit kay negative 70 si negative 85. Implication. Okay? The main contributor to the negative resting membrane potential is potassium. Why, Doc? Because its Nernst potential is closer to negative 70 millivolts. Closer to your RMP. Doc, di ko pa rin na-gets. Tanggapin na lang natin. Pag malapit ka sa RMP, okay, yung Nernst potential mo, ikaw yung nag-contribute. A little difficult to explain without going to the calculations and to the physics about it. That's basically the rule. The closer you are to the RMP, the more that you contributed to the RMP. Okay? Because the Nernst potential for both of these ions will contribute to RMP. Now, an action potential. An action potential will have the following characteristics. Board relevant. Okay? Number one, a stereotypical size and shape. Okay? Your nerve, for example, your neuron, will depolarize to the same extent, repolarize to the same extent. The next time you stimulate it, it will depolarize to the same extent, repolarize to the same extent. You stimulate it again, it will depolarize to the same extent and repolarize to the same extent. Hindi yung, Doc, medyo may anxiety ako or nagre-regla ako or gutom ako today Pwede bang hanggang dito na lang? Ganyan na lang ang aking action potential. Doc, pwede bang action potential ko ganyan na lang? Or ganito na lang, Doc? Okay? Hindi pwede. Okay? Stereotypical size and shape means you have same shape and size in terms of your action potential when we graph it. Okay? It will depolarize and repolarize to the same extent. Okay? So, stereotypical size and shape. Number 2 is propagating. That's another characteristic of a true action potential. Nakakahawang kuryente, nakakahawang action potential. When one neuron has it, okay, other neurons will subsequently have it. Okay? That, especially the one near to that neuron. Propagation. And then finally, the most board relevant characteristic, all or none. Okay? If this is negative 70 millivolts, your RMP, there is a membrane potential at a charge, okay, wherein if we reach it, an action potential is inevitable. If you don't reach it, an action potential will not happen. So that is what we call now your threshold. The actual value of threshold is will vary according to references, not really agreed upon by scientists. So for discussion purposes, for example, sabihin lang natin negative 40. Ang nangyayari ganito, if you have positive ions going into the cell, it will make the cell more positive, right? So from negative 70 millivolts, aakyat ka ngayon, negative 69, 68, etc. Eventually, you will reach a value called threshold. Sabihin mo, negative 40 millivolts. Pag naabot mo yung threshold, boom! An action potential will happen. Okay? Paano kung hindi ko ma-achieve, Doc, yung threshold? No action potential. Nothing in between, no purgatory, Doc, only heaven or hell? Yes. That is what threshold means. That's what all or none response means. Okay? It's like a man standing at the edge of a cliff. He stands here, he won't die. He stands here, won't die. He stands here, won't die. He stands here, he will die. Once you reach this threshold, okay, that man will die. So ganun din in terms of the action in terms of all or none. You don't reach threshold, no action potential. You reach threshold, boom, jackpot, you will have an action potential. Okay? In terms of your neuron, okay, how does it work? In terms of your neuron, we have here what we call sodium gates, sodium channels, and potassium channels. So these are the channels involved in the nerve action potential. Yung sodium channels mo, at rest, tingnan nyo it will have what we call a sodium activation gate and a sodium inactivation gate. Your sodium channels involved in the nerve action potential is like an anteroom or antechamber. Yung anteroom or antechamber, it's like a room before the actual room. You see antechambers, anterooms, for example, in sa mga sa mga motel, nakikita yan yung mga antechambers or anterooms. An antechamber or anteroom is a room with two doors. Okay? A room with two doors. Like for example, sa mga mot-mot, okay, meron yan. So itong sodium channel mo dito, yung antechamber niya, the sodium activation gate at rest is closed. The sodium inactivation gates at rest is open. Okay? The potassium channels, meanwhile, is not an anteroom antechamber. It will have a single door here. So when you have depolarization, what happens? Depolarization is when you make the cell more positive. So when you make the cell more positive, actually, you will have sodium going into the neuron. So that will happen when the sodium activation gates open. When the sodium activation gates open, because you have a lot more sodium outside of the cell than inside of the cell, sodium will now go in. Sodium is positively charged, so it will make the inside of the cell more positive, and it will result in depolarization. Everything that goes up must come down. So every depolarization will be followed by repolarization. So how does repolarization occur? You have the sodium inactivation gates, two events. In repolarization, number one, the sodium inactivation gates will close. This will prevent further entry of sodium. The other one is that the potassium channels will open. That's the second event in repolarization. If potassium channels will open, what do we expect? Do we expect potassium to go into the cell or do we expect potassium to go out of the cell? Well, you need to remember, sodium is the number one cation in the ECF, extracellular fluid. But potassium is the number one cation in the ICF, intracellular fluid. So pag bumuka ka, ang potassium channels mo, dahil mas marami kang potassium sa loob ng neuron, sa loob ng cells, you will expect potassium to go out. Simply because of the concentration. Mas marami sa loob kaya sa labas. Potassium is positively charged. So when you have positive ions going out of the cell, you will make the cell more negative. You will now have repolarization. Okay? I didn't include here anymore yung drawing ng mga channels. Nandyan yan, may picture kayo dyan sa handout ninyo. Okay? But I just drew them for you earlier. Okay? Sodium activation gates, sodium inactivation gates. Take note of the synonyms. They might use this for exam. Sodium activation gate is M gate. Sodium inactivation gate is H gate. Okay? Again at this point, checkpoint. Doc, nagpo-pause po ako, nagre-rewind ng mga sinasabi nyo. If you're doing that, please stop. You need to train yourself. Physio is always the first subject in top-notch. Ever since we started, palaging dapat ako yung una para ma-set yung tone at kung paano mag-aral yung mga estudyante. So, pasensyaan nyo na kung nagtuturo ako sa kung paano mag-aral continuously for the next few hours. Stop pausing, rewinding. Okay? You're probably not fast-forwarding my lecture. I doubt if you're naka-fast-forward, naka-times 2 yung speed ko or naka-times whatever. Or mabilis na rin ako kasi magsalita eh. But please do not pause rewind because if you do that, you're going to get very frustrated because you're only able to finish one topic or two topics a day. Okay? Dahil nakakapagod mag-pause, mag-rewind. And na-train yung utak mo na, okay, I have opportunity to review pag na-miss ko siya. So ngayon, you're going to do it again and again. Hindi katulad ng pag-train mo yung utak mo na, I will not pause and rewind this. So I have to pay attention. I have to write. Okay? So please avoid rewinding this video. That's my personal advice. Of course, if you really want to rewind, if that's your style, go ahead. Okay? We will respect that. But be aware. From our experience with our past students, they're going to have a more difficult time compared to someone who has practiced at the start na hindi nagpo-pause rewind maneuver. Okay? Next, propagation of your action potential. We have a term called conduction velocity. How fast that action potential will travel. So that's conduction velocity. This is determined by three things. Uy, naka-bold highlight, Doc. Importante kaya yan? Malamang. Fiber size and myelination. Rule. The thicker the nerve fiber, the faster. Myelination. The more myelinated, the faster. Okay? So, conduction velocity is actually a formula. Previous board exam question, they had asked the student to compute. The formula is distance over latent period. Okay? So, I have, for conduction velocity, some more stuff listed in your handout. Later on, okay, tonight, while you are reviewing and looking at the part of the notes that I didn't discuss here, take a look at that. Yung formula for conduction velocity. And some of the other stuff I said about conduction velocity listed there. So, action potential conduction velocity, again, will be enhanced by rapid sodium channel gating, wide axons, myelination, and saltatory conduction. Okay? Doc, ano ba yung mga saltatory conduction? Ek na yan. Okay. Drawing. You have here a nice picture, okay, of what a neuron is. Okay, a neuron will have, ang classic nung grade school, high school. A neuron will have three basic parts: dendrites, soma, axon. In med school, they modified that. Ngayon, mas naging complicated. A neuron will have dendrites. Okay, those dendrites that you see here, they will contain receptors for neurotransmitter. So, may receptor for neurotransmitter sa dendrites, may receptor for neurotransmitter din sa soma. After the dendrites, you have the initial segment. Okay, the initial segment, that's the first part of the axon. That's why we call it initial segment. The initial segment is also called your axon hillock. Okay, your axon, okay, will then be divided into myelinated portions and unmyelinated portions. So these are the unmyelinated portions. The unmyelinated portions are what we call the nodes of Ranvier. Okay? The nodes of Ranvier. From your axon, we will now find neural fibrils. Neural fibrils are branches of the axon. And at the distal ends, we're going to find your terminal boton. So those are the tips of your neuron. So again, okay, we have dendrites, we have soma, we have the axon hillock, we have the axon. That axon will have myelinated portions. Myelin acts as an insulator. And then from here, the axon, you're going to see neural fibrils. And at the distal tips, you're going to see your terminal botons. Okay? Nerve fiber or nerve. Nerve or nerve fiber is synonymous. When you hear the term nerve or nerve fiber, it's a bundle of axons joined together, like a bundle of rope fibers. Okay? Nerve or nerve fiber. Now, again, God is the greatest engineer. Everything was engineered to perfection. Everything had an engineering reason. Why did God give you myelin? Why do you have what we call saltatory conduction across the nodes of Ranvier, the unmyelinated portion of your axon? The reason for that is has something to do with physics. If you remember your basic high school physics, the longer the wire, the electric wire, the farther you are away from the source of the electricity, the farther you're away from the source of the current, the greater the resistance. The wire itself will provide some sort of resistance. So this is problematic when it comes to very long electric wires. Okay? Your nerve, your axon is just one long wire. You want the same strength of the signal to be preserved across that long wire. What if you're, for example, vagus nerve? Ang vagus nerve mo is from the brain all the way to your large intestines, transverse colon. So may vagus nerve ka sa head, may vagus nerve ka sa chest, may vagus nerve ka all the way to your abdomen. It's very long. Gusto mo, okay, ma-overcome yung resistance, yung decrease in current, pagdating dun sa dulo ng vagus nerve. So ano yung gimmick natin? How do you prevent the transmission of signal from decreasing the farther you're away from the source? Ang gimmick natin is this. In each nodes of Ranvier, we are basically regenerating the action potential. By regenerating the action potential in each nodes of Ranvier, whether you are near or far away from the source, you will have the same strength of signal because you produce the same action potential. So this is now the value of having saltatory conduction. Because you have an insulator in your myelin, eto lang yung conductor, yung nodes of Ranvier, yung action potential will be regenerated at each nodes of Ranvier. Okay? Axon hillock, this is where an action potential starts. Previous board exam question. Saltatory conduction is transmission across the nodes of Ranvier. The more myelinated you are, the faster the conduction velocity. The thicker the nerve fiber, the thicker the nerve, okay, the faster the conduction velocity. At the terminal botons, what happens? Must know. At the terminal botons, once the action potential has reached this terminal boton, it will open up the voltage-gated calcium channels. As the name implies, voltage-gated. It's activated pag may kuryente, pag may voltage. Voltage-gated eh. Pag na-activate yan ng action potential, it will open. When it opens, what will happen do? Calcium influx, calcium efflux. Dahil mas maraming calcium sa labas ng cell kaysa sa cytoplasm ng cell, calcium will go in. Intracellular calcium will increase. The rise in intracellular calcium will be the one to trigger exocytosis, okay, of these presynaptic vesicles. These presynaptic vesicles will contain neurotransmitters. Okay, the neurotransmitters are then released into a space between neurons that we call synapse. One neuron can connect with 50,000 other surrounding neurons. So, ang isang neuron may 50,000 na kapitbahay. Okay? They are not linked directly. There's a space between them called synapse. So, how do neurons communicate with one another? They will utilize neurotransmitters. Those neurotransmitters can either be 1. Excitatory, 2. Inhibitory. When you say excitatory, they will cause an action potential in the next neuron. When you say inhibitory, they will prevent an action potential in the next neuron. Okay? So that's how it works. Okay? Axon high lock, where an action potential is initiated. Saltatory conduction, regeneration of action potential across the nodes of the Van Okay? Eventually, the terminal photons, previous board exam question, what will happen? Most board relevant here. Okay? Voltage-gated calcium channels will be activated, causing calcium influx, a rise in intracellular calcium. That rise in intracellular calcium will then trigger exocytosis of neurotransmitters. It can either be excitatory or inhibitory to the next neuron. Your neurotransmitters, what is their function? They function as chemical messengers. Okay? They may be excitatory or inhibitory. Okay? Let's discuss some of the more famous neurotransmitters. There's a lot of ways to classify neurotransmitters. So this is the classic neurotransmitters now. Previous board exam question, decade ago, okay, 2011. It was so notable, several students asked me, Sir, tinanong po sa exam namin, what is the most important neurotransmitter of them all? What is the most important neurotransmitter of them all? A. Acetylcholine, B. Norepinephrine, C. Serotonin, D. Dopamine. Sabi nila, anong tamang sagot, sir? Sabi ko, Doc, there's no answer written in your textbooks. And then it's for a good reason. All of those neurotransmitters are important at their respective sites. So that's actually a little bit weird. What's the most important neurotransmitter of them all? It's like asking me if you have 20 children, sino yung favorite mo? So that's very subjective. But if I'll be forced to answer that question, what's the most important neurotransmitter of them all? I'll probably answer acetylcholine. Why? For that simple reason that it's found in the greatest number of sites. You're going to find it in the neuromuscular junction, in the autonomic nervous system for both sympa and para, in the basal ganglia, in the motor cortex. So it's found in the greatest number of sites. So that's probably going to be my answer. Acetylcholine is different from the other neurotransmitters in that, okay, degradation will happen first before reuptake. What do I mean? Usually, ang gimmick, kung halimbawa, ito yung neurotransmitter mo, neurotransmitter X. Pag sinecrete yan into the synapse, ang usual gimmick natin, pag hindi mo na kailangan, ibabalik mo yan, what we call reuptake, and then you break it down, what we call degradation. The only exception to this rule is acetylcholine. Ang acetylcholine, pag nakadikit yung acetylcholine mo, doon sa receptor niya, okay, sa acetylcholine receptor, binabasag mo na using acetylcholinesterase. So you begin the process of degradation. And once you have formed your degradation products like choline, okay, yun ang nire-reuptake mo. So nauna, nabaligtad siya. Okay? So, acetylcholine, previous board exam question, that's why nakabold italicized sa handout nyo. It's a neurotransmitter that opens the sodium-potassium pump that depolarizes the muscle end plate to a value halfway between the sodium and potassium equilibrium. It can trigger rapid eye movement sleep, the previous board exam question, and you're going to see decreased levels in Huntington dementia and Alzheimer dementia. Okay? So, acetylcholine. Those are the actions, lot of locations. Norepi, epi, dopamine. Dopamine, norepi, and epi are collectively called your catecholamines. When you hear the term catecholamines, it means it's a derivative of tyrosine. Tyrosine, symbol Y, chemical symbol Y in biochem, tyrosine. It's a tyrosine derivative. Okay, your catecholamines. Okay? There's a famous mnemonic that I want you to remember. That mnemonic is created by Ronnie Baticolon, 2008 pa, na-create niya. That mnemonic is this one. Pare, true love does not exist to me. Pare, phenylalanine, true, tyrosine, love, levodopa, does, dopamine, not, norepinephrine, exist, epinephrine, to me, thyroxine, melanin. Pare, true love does not exist to me. It will tell you the sequence of substrates, intermediates, and products for tyrosine derivatives. Tyrosine comes from the amino acid phenylalanine. From tyrosine, you can form your catecholamines, dopa nor epi and epi, thyroid hormone, and melanin. Okay? Be careful. Okay? The students commonly confuse choices with the first letter. Like, saan galing ang melanin? Galing ba siya sa tyrosine? A? Threonine? B? Or tryptophan? C? Oh, basta letter T yun eh. Oh, nakaka-confuse, right? So, melanin is tyrosine. Okay? How will you remember na hindi siya tryptophan? We have another mnemonic called tripmoshano. Tryptophan comes from melatonin, melatonin. Serotonin, siya. Niacin, no. Tripmoshano. Melanin is from tyrosine. Melatonin, the one for the circadian rhythm, is from tryptophan. Okay? Let's go back. So, norepinephrine, dopa, epinephrine are your catecholamines, comes from your tyrosine. Things that are important. Norepi and epi in the United Kingdom, okay, the imperial countries, we could call them noradrenaline, adrenaline. Board relevant. Between the two, we know that they stimulate the sympathetic nervous system, right? Okay, the one that you need to remember is beta-2 effect. Your epinephrine will have greater beta-2 effect compared to norepinephrine. That's why it's epinephrine that's the one that we give to patients with status asthmaticus. Because if you have status asthmaticus, severe asthma, you want to cause bronchodilation. So you're going to need beta-2 agonist for that. And the one with the more powerful beta-2 agonist effect, okay, is epinephrine rather than norepi. What do you call a doctor giving norepinephrine to a patient with status asthmaticus? That's a doctor waiting for a lawsuit to happen. Okay? Because you don't give norepi to a patient with status asthmaticus. You need to give them epinephrine because epinephrine is the one that's effective for beta-2. The other claim to fame, okay, of norepi and epi. Norepi is the neurotransmitter mainly produced by your postganglionic neuron of the sympathetic nervous system. So postganglionic sympathetic neurons, think of norepinephrine. Epinephrine is the main secretion of your adrenal medulla. This is your adrenal gland. It has a cortex and a medulla. The medulla will produce 80% epi, 20% norepi. So from here on, I'm just going to call it epi norepi. Okay? Dopamine. Okay? Dopamine is secreted in several sites of the brain. So for example, dopamine can be secreted by the substantia nigra, complete your handout, pars compacta of the brain. The substantia nigra pars compacta of the brain will produce the dopamine that's involved in fine-tuning of movement. If you lack this, if you have damage to their substantia nigra pars compacta, you're going to see Parkinson's. Okay? Other areas of the brain can secrete dopamine also. Like your hypothalamus can secrete dopamine. The dopamine secreted in your hypothalamus has specific function. It's not really for movement. Hypothalamic dopamine, the function is that it will inhibit prolactin. That's why hypothalamic dopamine is called by another name. We also call it your prolactin inhibiting factor, PIF, or prolactin inhibiting hormone, PIH. Okay? Dopamine, previous board exam question, decrease in Parkinson's, increase in schizophrenia. So I actually asked one of the neurologists that we know, can schizophrenia and Parkinson's happen at the same time? The same patient? Because if you're going to think, based on this, kung mababa ang mababa ang dopamine sa Parkinson's, tumataas sa schizophrenia, dapat mutually exclusive. Hindi dapat nangyayari yan in the same patient. Kaya, pwede. Bakit daw pwede? Sabi ng mga neurologists. Because they involve different areas of the brain. One area can have low dopamine, the other can have high dopamine. It can coexist. You can have a Parkinson patients with schizophrenic manifestations. Okay? Serotonin. Serotonin has been called the happy hormone. Why? Low levels of serotonin, okay, is associated with depression. That's why we give our patients SSRIs if they have depressions. SSRIs, serotonin-specific reuptake inhibitors, all in a with the goal of increasing serotonin levels. Okay, give me a food that's rich in serotonin. Chocolates. Okay, that's why you feel happy. Mnemonic lang to guys, ha? That's why you feel happy when you eat chocolates because it has the happy hormone, serotonin. Nitric oxide is NO. Please do not confuse this with nitrous oxide, which is N2O. Okay? Previous board exam question, just recent. Nitric oxide is an inhibitory, non-adrenergic, non-cholinergic neurotransmitter. It's a permeate gas that is synthesized as needed. It's not stored in vesicles. Write that down. Not stored in vesicles. It's an inhibitory neurotransmitter, always. And it is a vasodilator. When you hear nitric oxide, vasodilator, inhibitory neurotransmitter. Or, to be more specific, okay, inhibitory, non-cholinergic, non-adrenergic neurotransmitter. Okay? Next, glycine, GABA, and glutamate. Again, one of the disease common among medical graduates taking the boards is what I call the first letter syndrome. So they know the answer but only the first letter, and it becomes a problem. For example, when the choices have the same first letter. So for example, they can ask which of the following is an excitatory neurotransmitter? A GABA, B glutamate, C glycine. So isipin ng student, basta letter G yung nagsisimula. So first letter syndrome. So, pag ganon, dapat kapag mga first letter, dapat inumpisa mong amuyin kung ano yung pwedeng lumabas sa boards and how they can ask the choices. Paano kayo pwedeng lutuin? Take a point of view minsan ng mga examiner mismo. So, glycine, GABA, and glutamate, they start with the letter G. Among the three, only one of them is excitatory. And that is glutamate. So, this is the one that is excitatory. The other two are inhibitory. So how will you remember the excitatory and glutamate? Well, okay, it's the main excitatory neurotransmitter in the brain. Okay, mnemonic, think of yourself eating a cup full of monosodium glutamate. So malamang if I give you monosodium glutamate, you'll feel excited. So excitatory, okay, glutamate. Next, glycine and GABA. Both of them are inhibitory neurotransmitter. Their claim to fame, glycine is the main inhibitory neurotransmitter in the spinal cord, while GABA is the main neurotransmitter in the brain. So how will you remember? GABA, may be, brain, main inhibitory neurotransmitter in the brain. Next, glycine. Yung letter I niya mukhang spinal cord. So ito yung spinal cord. Sorry, medyo pilit. Okay, it works for me. Okay, pagdating sa exam, you're all super stressed. You have all of these things. Minsan nakakita ka na ng mga, okay, glycine. Yung letter I yung mga spinal cord. So, yun yung spinal cord. So, glycine is the main inhibitory neurotransmitter in the spinal cord. GABA, main inhibitory neurotransmitter in the brain. They act on chloride, for example. Chloride channels causing chloride influx. Chloride is negative. It will make the cell more negative. Inhibition of action potentials. Okay? Glutamate and substance P are the neurotransmitters involved in fast pain and slow pain. Okay? What is fast pain and slow pain? You usually feel this in sequence. Fast pain is also called acute, okay, electric pain, pricking pain. While slow pain is burning, aching, throbbing pain. They are usually felt in sequence, fast pain first, and then followed by slow pain. For example, you get a pin, that pin touches your skin, you will first feel fast pain, that acute electric pricking pain. And then after some time, that area will throb, burn, and ache. So you will feel slow pain. Okay? So, how will you remember that fast pain is glutamate, slow pain is substance P? Slow pain, substance P, of course, yung acronym, SP, substance P, slow pain. So, madali lang. How about yung fast pain, doc? Any way to remember that? Any memory aid for us? Just pronounce it really, really fast. Glutamate. If you pronounce it really, really fast, glutamate, you will remember it. So medyo corny, pero it works. Once again, glutamate. Pronounce it really, really fast. Okay? Let's now go to muscles. Previous board exam question, they actually did this. They asked about the function of muscles. So most of us will remember muscles movement, Doc. There are other functions of muscles. That's why I've listed here. Parang napaka out of place minsan. Di ba, Doc? Parang napaka mababaw pag grade school yung function of muscles. I've added it here because it's been asked previously. So the functions are listed here. It's not just movement. Previous board exam question. The yellow boxes, when I add that in your handout, it's not something that you should ignore. That's basically my voice, okay, giving you a short lecture through written text kapag may yellow boxes dyan sa handout nyo. Okay? Highlight, read. Okay? Yung mga nakalagay dyan sa yellow boxes. Do not ignore. So, previous board exam question, largest muscle, gluteus maximus, strongest muscle by weight, masseter in the jaw. So, the strongest muscle is not actually your tongue. That's a common misconception. I used to think it was the tongue also. It turns out the strongest muscle is actually the masseter, not the tongue. Okay, now, let's discuss the types of muscles. We have your skeletal, cardiac, and smooth muscle. That's the first. Maraming divisions to So, isa-isayin natin kung paano isa-subdivide. So, skeletal muscle first. You have your, let's use our visualizer para mas maganda. Okay? So, muscles are divided into 3. Okay? So, your muscles, you're going to find your skeletal muscles. Okay? Cardiac muscles. And your smooth muscles. Skeletal muscles have 2 types. Okay? Intrafusal and extrafusal muscle fibers. Okay? Intrafusal fibers will make up 5% of your skeletal muscle fiber. Extrafusal will make up 95% of your muscle fiber. Okay? Intrafusal muscle fibers are synonymous with the term muscle spindles. So, muscle spindles, okay, these are specialized muscle fibers that detect changes in muscle length. Okay, muscle spindles, they detect changes in muscle length. Muscle spindles are considered part of your proprioceptors. You've heard of that term before, proprioceptors. These are, they are for position sense, basically, your proprioceptors. So, your proprioceptors are made up of muscle spindles and Golgi tendon. Muscle spindle, they detect changes in muscle length. Golgi tendon, they detect changes in muscle tension. Mnemonic. Muscle spindle, muscle length detection. Golgi tendon, tension, muscle tension detection. They detect changes in muscle tension. So, intrafusal muscle fibers, synonymous with the term muscle spindles. Be careful, commonly nakakalimutan yan. Extrafusal muscle fibers, meanwhile, come in 2 basic types. Your type 1 and type 2 muscle fibers. Extrafusal muscle fibers, this is for ordinary, run-of-the-mill, voluntary skeletal muscle contraction. Made up of 2 types, type 1 and type 2. Okay? Mnemonic from here on. Think of 1 slow, red ox with a perfect posture. Why did I use the term? 1 slow red ox with a perfect posture. Okay, so use mnemonic. Okay, decades old. Okay, type 1 is also called your slow twitch or slow muscle fiber. Okay, type 1 is also called your red muscle fiber. Type 1 is oxidative. It uses oxygen a lot. Okay, and the best example of where you can find type 1 predominating, the postural muscles of the back. Type 1, in one word, it is for muscle endurance. Okay? Why is it for muscle endurance, Doc? It's very rich in myoglobin, the protein that stores oxygen inside muscles. So 1, slow twitch, red. Red muscle fiber, again, it is red because it contains plenty of myoglobin. Ox, it's oxidative. And the best muscle where you can find a predominant type 1, postural muscles of the back. Okay? All of our skeletal muscles will have both type 1 and type 2. But usually, one will predominate. Mas madami siya compared to the other. In the postural muscles of the back, you will require what? Endurance or power? You require both, but which one do you require more? You will require more endurance rather than power for the postural muscles of the back. So the postural muscles of the back will utilize type 1. Okay? Type 2 is just the complete opposite of this saying. Type 2 will be fast, white, non-oxidative. And the best example of where you can find that is your EOMs, your extraocular muscles. Doc, why? Why EOMs? So type 1 is for muscle endurance, type 2 is for muscle power. The EOMs will require power more than endurance. You don't rotate your eyeballs all the time, but when you do rotate your eyeballs, move it up, down, left, right, you want it to be very powerful and very fast. That's why God, the greatest angel of them all, gave it more type 2 rather than type 1. Okay? So type 1, type 2, those are the types of extrafusal muscle fibers. Commonly, ang mistake ng student, pag tinanong ko, what are the types of skeletal muscle fiber? Doc, type 1, type 2. No, mali. Type of skeletal muscle fiber is intra and extrafusal. Ang type 1 and type 2, yan ang type ng extrafusal muscle fiber. Okay? Next, cardiac muscle come in 3 types. Ventricular cardiac muscle, ventricular muscle, atrial muscle, and your pacemakers. Our apologies, naglako yung isang equipment namin, so we have to restart basically itong portion na to and redo everything. Actually, natapos na ako all the way until the end of the cell module nung nangyari siya. So, let's discuss cardiac muscles. Again, okay, we have 3 types, ventricular, atrial, and pacemakers. Pacemakers, these are specialized cardiac muscles capable of what we call self-excitation that can excite themselves, stimulate themselves. So ventricular, atrial, and pacemakers. Let's discuss first ventricular action potential and then compare it with pacemaker action potential. So this is your ventricular action potential. Okay. We have phase 0, phase 1, phase 2, phase 3, phase 4. Phase 0, 1, 2, 3, 4. Okay. So these are the 4 phases, okay, of your ventricular action potential. Phase 0 is depolarization caused by sodium influx. Phase 1 is partial repolarization caused by potassium efflux. Paglabas ng potassium out of the cell. Phase 2, okay, is your plateau phase. You don't have an increase or a decrease in the membrane potential because during this time, phase 2, calcium influx is exactly equal to potassium efflux. Okay? So, habang lumalabas yung positive ions, habang mayroon kang potassium efflux, may pumapasok na positive ions, calcium influx. And they will basically cancel each other out, so you will have no change in terms of the membrane potential or intracellular charge. Phase 3 is complete repolarization, okay, potassium efflux. So in phase 3, the calcium channels are already closed, but the potassium channels are still open, causing complete repolarization. And finally, phase 4. Phase 4 is your resting membrane potential for the cardiac muscle. Phase 0, 1, 2, 3, 4. Okay? So, ang difference niya, if you will remember your nerve action potential, yung nerve action potential, depolarization, and then repolarization. Habang itong ventricular action potential, meron kang depolarization, okay? And then sa halip na bababa ko kaagad, okay, nagkaroon ng phase 2, ng plateau phase. So, ano implication ng doc? The implication na may phase 2 ka is that the duration of the cardiac action potential, the duration of your atrial action potential, ventricular action potential, the implication is that it is longer than the nerve action potential. And this is by design. Sinadya ni God yan, as the greatest engineer of them all. Ba't niya sinadya? Okay? Sinadya to na longer ang duration ng ventricular action potential to ensure that you will have a limited heart rate. Okay? If you have longer duration ng cardiac action potential, you will form less cycles per minute compared to the nerve action potential. That's why your maximum heart rate, okay, is actually a formula. It's just your 220 minus your age. Nothing more than that. Okay? What if hindi ka love ni God? Tapos sinabi niya, okay, baka si Prince. Itong si Prince, hindi ko to love. So, ang gagawin natin, pagtipan natin, lagyan natin ng katulad ng nerve action potential yung cardiac muscle niya. What will happen? Kung wala itong ano na to, phase 2 plateau, calcium 2+, okay? Ang mangyayari niyan is that you will form more cycles per minute. Heart rate now will be what? Greater than 220, definitely. Okay? And with that kind of heart rate, halimbawa, if you have a heart rate of 1,000 beats per minute, what will happen? The heart is virtually closed. Okay? So, ayaw ni God yun. Hindi magandang engineering ano yan. Not enough time for ventricular filling. So, you will slow down the heart rate by having, okay, cycles na longer ang duration for your cardiac muscle. Okay? The one that will differentiate the nerve action potential from the cardiac action potential is this one, your phase 2. So remember, okay, phase 2, plateau, calcium 2+. Okay, the one that will prolong the duration of your action potential. Okay? Next. Contrast this, so we have your cardiac action potential, right? Contrast your action potential in the atrium and ventricles with that of the pacemakers. Your pacemakers are the SA node, AV node, bundle of His, Purkinje fibers. They're capable of self-excitation, okay, or what we call autorhythmicity. Let's take a look, okay, and specifically discuss your SA node action potential. In the SA node action potential, there are only 3 phases. You have phase 4, okay, phase 0, phase 3. Phase 4, phase 0, phase 3. Phase 4, okay, is your unstable RMP. Unstable resting membrane potential. This is caused by sodium influx, slow sodium influx, utilizing specific sodium channels that we call IF channels. Okay? Slow funny sodium channels, or what we call IF channels. Phase 0, meanwhile, okay, is depolarization caused by calcium influx. Okay? And finally, phase 3 is repolarization caused by potassium efflux. So, let's take a look. Phase 4, so this is your threshold, for example. Phase 4 is your unstable RMP. Okay? The one that causes this phase 4 is what we call your slow sodium influx utilizing IF channels. Now, this slope has been called unstable kasi hindi siya constant. You can actually change the slope to make it sharper, steeper, or to make it flatter. What do I mean? For example, okay, this is actually how we control heart rate. The sympathetic nervous system acting on beta 1, okay, will increase the sodium influx. So when you increase the sodium influx, what will happen? You will now reach threshold much faster, okay? And with that, the duration of your SA node action potential will become shorter compared to the usual. So you will now be able to form more cycles per minute. This will now cause an increase in heart rate. So nakita mo si Crash. Bakit bumilis ang tibok ng puso mo? Basically, bumilis yung influx ng sodium papunta sa SA node caused by the sympathetic nervous system. Naging sharper, steeper yung slope ng phase 4. Na-reach mo yung threshold much sooner, okay, than usual. So you will have shorter duration ng cycle, okay, more cycles formed per minute, increase in heart rate will result. The opposite, parasympathetic nervous system acting on your muscarinic type 2 receptors, meanwhile, will decrease the sodium influx. Pababagalin niya. When you decrease the sodium influx, okay, what will happen? The duration of your action potential will be longer than usual. So you will now form less cycles per minute, resulting in a decrease in heart rate. So crucial, okay, even though calcium is the one that will cause depolarization in your SA node action potential, sodium is the one that will still determine heart rate. And it does so using, okay, yung unstable RM mo, yung controllable na influx ng sodium mo, okay, done here, okay, via your IF channels. So IF, the F there literally means funny, okay, so why would they call it funny, Doc? Nagpapatawa ba yan? Well, the reason for that, nag-usap-usap yung mga scientists na discover na itong mga IF channels. Sabi ng isang scientist, Tol, tingnan mo to. Ano yan, Tol? Tingnan mo tong sodium channels na ginagamit sa SA node. Ang bagal ng pagpasok ng sodium, oh. Oo nga, no. Di ba dapat mabilis yan katulad sa nerve? Oo nga, eh. Dito mabagal. Oo nga, no. Sobrang bagal. That's so funny. Ha, ha, ha. So, pinangalanan nila yung literally slow funny sodium channels. IF channels. They found it funny themselves na mabagal yung pagpasok ng sodium. Natawa na sila. Mababaw lang, aligahan ng mga physiologists. Okay? So, this is your SA node action potential, the one that determines your heart rate ultimately. Okay? Next, your smooth muscles. Smooth muscles come in two types. Okay? Your multi-unit smooth muscles, okay, and your unitary smooth muscles. Okay? The multi-unit smooth muscles do not have gap junctions, while the unitary smooth muscles have gap junctions. So because unitary smooth muscles contain gap junctions, they're able to contract together as one. Okay, they have syncytium. So the best example of this is in the uterus. Okay, so your unitary smooth muscle is the one responsible for what we call coarse or gross motor control. Okay, while your multi-unit smooth muscles, they don't have gap junctions. They're more, the units for contraction is smaller, okay, and tend to act more independent compared to unitary smooth muscles. That's why the multi-unit smooth muscle is the one responsible naman for fine motor control. Examples. If the unitary smooth muscles, the best example is the uterus, okay? Your multi-unit smooth muscles, the best example of where you can find them are the smooth muscles controlling pupil size. Okay? So if you want gross motor control, okay, coarse motor control, if you want the smooth muscles to contract together as one, it was given unitary smooth muscles. Like for example, uterus, it was given unitary smooth muscle so that the entire uterus will contract together in expelling the fetus. Okay, during childbirth. Di naman pwedeng yung upper one-third nagko-contract, yung lower one-third, chillax pa rin, yung middle one-third, undecided. So, unitary ang binigay dyan. Yung multi-unit smooth muscles naman, okay, is for fine motor control. What will happen, for example, if the smooth muscles controlling your pupil size ang nilagay dyan, unitary instead of multi-unit? If that happens, well, there will only be two pupil sizes, 0 and 10. Okay, either completely closed, completely open. So it's the multi-unit smooth muscles which will allow you to have gradations in terms of pupil size. So this is the one for fine motor control. Okay? So skeletal, cardiac, and smooth muscles. Again, okay? Muscles are of three types: skeletal, cardiac, smooth. Skeletal ang voluntary, the other two are involuntary. Skeletal muscles, okay, under the somatic nervous system. Cardiac and smooth, this is under your autonomic nervous system. Skeletal muscles are of two types. What are the two types? Hindi siya type 1 and type 2. Yun yung common mistake ng students dito. Skeletal muscles have intra or extrafusal muscle fibers. 5% intrafusal, 95% extrafusal. Intrafusal are also called muscle spindle. They detect changes in muscle length and are part of what we call proprioceptors. Extrafusal is the ordinary run-of-the-mill skeletal muscle fiber that contracts, okay, for muscle movement, muscle contraction. So extrafusal is the one divided into type 1 and type 2. Sino yung red? Sino yung slow twitch? Sino yung for muscle endurance? Okay, that's type 1. One slow red ox with a perfect posture. The other one is type 2. That is white. That's for muscle power. Okay? Cardiac, 3 types. Ventricular, atrial, muscle, and your pacemaker. Okay? Ventricular, atrial muscles, the cardiac action potential, phase 4, 0, 1, 2, 3. Phase 0, 1, 2, 3, 4. Phase 2 is calcium influx balancing potassium efflux. Pacemaker action potential, like your SA node, will only have 3 phases. Phase 4, non-stable, phase 0, and phase 3. Okay? And then finally, we have your smooth muscles made up of 2 types, multi-unit and unitary. Unitary, they are united. They contract together as one using gap junctions. Multi-unit, okay? No, multi, kanya-kanya. So, no gap junctions. The one for coarse motor control, unitary, like your uterus. The one for fine motor control, okay? The smooth muscles controlling pupil size. Okay? So, general overview, we'll now tackle them, okay, the finer details in our discussion here. So again, skeletal, cardiac and smooth muscles are types of muscles. Skeletal, intrafusal, extrafusal. Cardiac, we have atrial, ventricular pacemakers. And then smooth muscles, we have your unitary and multi-unit smooth muscles. One slow red ox with a perfect posture will be our mnemonic. Okay, the postural muscles of the back, you need more endurance rather than power. So it is given more type 1. While the EOMs, extraocular muscles, are given type 2 more than type 1 because you require more power rather than endurance for EOMs. You don't rotate your eyeballs all the time, but once again, when you do want to rotate or move them, you want it to have power. Okay? The sarcomere is the functional and structural unit of your skeletal and cardiac muscles. Sarcomeres are only seen in skeletal and cardiac muscles. Smooth muscles have no striations. That's why they were called smooth. Smooth muscles have no sarcomeres. Okay? So, a sarcomere is an area between two Z lines. Okay? The Z lines are the borders. The M line is the one in the middle. Okay? It is made up of thick filaments and thin filaments. So this is your thick filaments, okay, made up of myosin, interspersed with thin filaments. Your thin filaments are actually not just made up of actin. They're actually made up of, okay, actin, tropomyosin, and troponin. Okay, so be careful. Okay, common misconception yan na kapag sinabing thin filaments, iniisip lang actin. It's actually actin, tropomyosin, and troponin. So, let's take a look. Okay, you've heard of these terms before. A-band, H-band, I-band. Ano ba yung mga yun, Doc? Okay, when you hear the term A-band, it refers to the entire length of your myosin, entire length of your thick filaments. So, from this point all the way to this point, that is your A-band. Okay, your H-band, okay, your H-band is an area inside the A-band, okay, that is purely myosin. No thin filaments na intersperse. So, ano yung area na yon? From here to here. Okay? That will be your H-band. Okay? That will be your H-band. From this point up to this point. Okay? Yung thick filament na yan, walang naka-intersperse na actin. So, that area inside the A-band is what we call your H-zone. And inside the H-zone, there is an area with no myosin heads. So, eto yung area na yan. From this point up to this point, wala na yung mga myosin heads na ganito. So, that zone with no myosin heads, that's what we call your bare zone. Okay? The area near the Z-lines, made up of purely actin, with no thick filaments, no myosin interspersed, yung area na yan, that is what we call naman your I-band. Okay? So, may dalawang I-band sa dulo, I-band, I-band. A band, yung completely myosin lang. Okay? Ay, yung complete length ng myosin. Okay? H band, yung myosin na walang thin filaments na intersperse. Okay? And then, bare zone, yung part ng H band na walang myosin heads. Okay? So, take a look. When the muscles contract, ang basic gimmick niya ganito. You see this myosin heads here on both sides? Ang gimmick niya, didikit siya dito sa actin binding sites. Okay? Tapos hahatakin niya yon, itong mga actin na to, papunta sa center, papunta sa M-line. So, hatak dito, hahatakin niya yan papunta sa M-line. Mag-shorten ngayon yung sarcomere. Okay? Kapag nangyari yon, causing muscle contraction. Okay? So, ano pa yung mga dadagdag natin dito? Okay? Transverse tubules, sarcoplasmic reticulum, and actual muscle contraction. So, paano ba nangyayari yan? Okay? Let's take a look. Thick filaments, again, we have myosin. Okay, with myosin heads. Thin filaments, we have your actin. Okay, your tropomyosin and troponin. Tropomyosin is like underwear. It covers the actin binding sites. As long as that tropomyosin is there and covers the actin binding sites, walang myosin-actin interaction. Okay? Walang ano. Hindi didikit yung myosin doon sa actin binding sites. Troponin are regulatory proteins, okay, in your thin filaments. 3 types. Troponin T, troponin I, troponin C. Troponin T, okay, that's the one that binds with tropomyosin. T for tropomyosin. Troponin I, okay, is the one that inhibits actin-myosin interaction. It prevents myosin and actin from binding with one another. I for inhibition. And troponin C, this is the calcium that binds with, this is the protein that binds with calcium. C for calcium. Troponin T, T for tropomyosin. Troponin I for inhibition. Troponin C, C for calcium. In the smooth muscles, they don't have sarcomeres, they don't have tropomyosin, they don't have troponin. So in the smooth muscles, they have equivalent troponin proteins. So for example, they have caldesmone. Okay. Ano pa yung ano dyan? They also have calmodulin. Calmodulin is the equivalent of troponin C. Caldesmone is the equivalent of troponin I. So those caldesmone, okay, calmodulin, you see that in your smooth muscles. So Doc, paano ba talaga mag-contract ang smooth muscles? So the steps are listed here. Okay? I'm going to tell it to you. Pakinggan nyo muna. Just imagine in your head how it will actually happen. So, when skeletal muscles contract, you're going to need a motor neuron and then you're going to need the skeletal muscle fiber. Okay? So, imagine there's an action potential occurring in the motor neuron. Dendrites, soma, axon, neural fibril, terminal photons. Okay, so in the motor neuron, so on your left is a motor neuron, on your right, okay, is the muscle with its motor end plate. In between them is a synapse, okay, and this entire thing we now call the neuromuscular junction or NMJ. So once the action potential has reached the terminal photons nitong motor neuron mo, okay, voltage-gated calcium channels will open, and when that opens, it will now trigger the release, okay, of acetylcholine, the neurotransmitter acetylcholine, into the neuromuscular junction. That acetylcholine will bind with the acetylcholine receptor. This is your acetylcholine receptor. Okay? That acetylcholine receptor, we classically call it a ligand-gated ion channel. Haba ng pangalan, no? Ligand-gated ion channel. Ano ibig sabihin ng doc? Okay? Ligand means messenger. Okay? The messenger in this case is acetylcholine. The moment that messenger, that ligand, binds to the acetylcholine receptor, it will activate ion channels. In this case, the ion channel activated will cause sodium to go in, sodium influx, and will cause potassium to go out, potassium efflux. Okay? However, ang kailangan nyo tandaan dito is mas maraming sodium na pumasok kesa potassium na lumabas. Okay? Both are positively charged. But if overall, mas marami yung positive ions entering the cell than leaving the cell, well, you will now depolarize the sarcolemma. You will now cause their miniature end plate potential, MEPP, that will then submit to form your motor end plate potential, and that will basically depolarize this motor end plate. Okay? That depolarization, okay, will now cause an action potential in the muscle. That depolarization will then go to invaginations of the sarcolemma, invaginations of the cell membrane ng muscle that we call transverse tubules. So transverse tubules are still part of the sarcolemma, the cell membrane ng muscle. They are transverse or in a 90-degree angle to your myosin and actin. The moment depolarization has reached the transverse tubules, it will activate a structure there that we call DHPR, dihydropyridine receptors, DHPR. Ang DHPR, in turn, when it's activated, it will stimulate, okay, the ryanodine receptors found in the sarcoplasmic reticulum. The ryanodine receptors, okay, magpapasindak dyan. Your ryanodine receptors are basically calcium channels found in the SR, okay, that will release calcium into the cytoplasm. So the moment, by 1 to 1, nag-depolarize yung transverse tubules, na-activate yung DHPR, well, in turn, it will now activate ryanodine receptors to release calcium into the cytoplasm. Once that calcium is released, what will happen, Doc? That calcium will now bind, okay, with tropomyosin, ay with, tawag dito, troponin C. So, calcium will bind with troponin C. When it binds with calcium, with troponin C, it will now cause, okay, the displacement of your tropomyosin. Ano ibig sabihin? Imagine there are actin binding sites here. Normally, that actin binding site is covered by that underwear that we call tropomyosin. So the moment calcium binds to your troponin C, ang mangyayari, itong tropomyosin mo, gagalaw, matatanggal yung underwear, magmo-move. Okay? In such a way na may expose no ngayon yung actin binding sites. Kapag na-expose na yung actin binding sites, boom, boom! Okay? The myosin heads will bind directly with the actin binding site. Okay? No energy is required up to that point. Okay? Didikit na lang yung myosin doon sa actin. Like magnets. Okay? So the moment natanggal yung na-displace yung tropomyosin, expose yung actin binding sites, kaboom! Didikit yung myosin heads with the actin binding site. Okay? From this point, okay, you will now have cross-bridge cycling happening. Ano yung ibig sabihin ng cross-bridge cycling, Doc? Well, okay, several steps. Okay? First, we will have ATP binding with the myosin head. Orient yourselves. Okay? This is your actin. Okay? Ito. And this is your myosin with the myosin head. Okay? So, ang nangyari dyan, the moment ATP binds with the myosin, okay, it will cause detachment of the myosin head from actin. Bakit gusto mo mag-detach yan, Doc? Para makarami siya ng tatamaan na actin binding sites. Initially, nakatutok siya dito sa actin binding site na to. Well, gusto niyang tutukan yung susunod. So, the moment ATP binds to the myosin heads, it will detach from the actin binding site. Okay, the next step is to convert this ATP into adenosine diphosphate. This is what we call partial hydrolysis of ATP. When there is partial hydrolysis of ATP, you will now cause what we call recocking of the myosin heads. Recocking. Ano nangyayari dyan, Doc, sa recocking? Like you cock a pistol. When you cock a pistol, di ba, parang you're trying to pull it backward. Well, tingnan mo yung initial location na yung myosin head mo. When you cock it, okay, nagmo-move siya, parang siyang napupull backward. Ang nangyayari ngayon, initially, nakatutok siya sa actin binding site na to. Ngayon, pag nirecock mo yan, eto na yung tututukan niya, yung susunod na actin binding site. From here, okay, that myosin, the next step is that it will bind with the second binding sites na actin. Halimbawa, actin binding site 2. Initially, nasa actin binding site 1 siya. So, didikit. Pagkadikit niya doon, guys, itong adenosine diphosphate will now undergo what we call complete hydrolysis of ATP. We will completely consume that ATP. When that happens, when you have complete hydrolysis of ATP, okay, it will now cause what we call the power stroke. Okay? Basically, mag-flex itong myosin heads mo pag ganyan, okay, such that in both sides, di ba, hahatakin niya ngayon yung actin papunta sa M-line mo. Di ba? Sa right, sa left, okay, may nakadikit na myosin. Pag nag-power stroke, basically, it's going to pull actin towards the M-line. Okay? So you will now have skeletal muscle shortening. The sarcomere, specifically here, will shorten by around 10 nanometers. So you now have skeletal muscle contraction. Do this again and again, thousands of times, for you to have significant skeletal muscle contraction. What if I want to relax now, Doc? If you want to relax, just do the opposite. Remove calcium from troponin C. Bring back that calcium, okay, back to your SR using, this time, not ryanodine, using what we call naman SERCA, smooth endoplasmic reticulum calcium channel, SERCA, okay? And then, degrade the acetylcholine bound to your acetylcholine receptor, okay, using acetylcholinesterase, okay? So, those are the steps in skeletal muscle contraction and relaxation. Doc, key points. Ano yung possible questions sa exam? Well, their favorite is really to give you sequence questions. The choices will involve several combinations ng possible sequences, and you're going to be asked what is the correct sequence. So it's important for you to understand the story that I've just said, okay, regarding the sequence of events. Testmanship tip pagdating sa mga sequence questions na yan is to identify what happens first, what happens last. If you're able to identify kung ano yung pinakauna o pinakahuling nangyayari in a sequence of events, it will narrow down your choices. Okay? Other key points for the medboard, aside from the sequence questions. DHPR and ryanodine and SERCA. DHPR is found in the transverse tubules. Okay? Ryanodine receptors and your SERCA are found in your sarcoplasmic reticulum. Ryanodine receptors, they will release calcium, okay? Release calcium into your cytoplasm. SERCA is the one responsible for reuptake of calcium back to your SR. Okay? Ano pa importante rito? Partial hydrolysis of ATP will cause recocking of the myosin heads. Complete hydrolysis of ATP will cause the power stroke. Okay? So those are the steps in skeletal muscle contraction relaxation. We have also QR codes, okay, in your handout that will explain this again if you need to. But if you're listening right now to my lecture, taking down notes and listening, ayos na yan, buhay na tayo. If you want some visual aids to help you just type skeletal muscle contraction on YouTube. They have excellent animations there regarding the cross-bridge cycle. Okay? Isotonic and isometric contractions. When you hear the term, isometric, meter, length. Okay? Same length, same meter. Ano ibig sabihin nun? In isometric contraction, the muscles are contracting, but muscle length is held constant. It's not changing. Is that possible, Doc, for muscles to contract, but their size won't change, their length won't change? Yes. The best example of this is pushing against an immovable wall. If you try and push an immovable wall, your muscles are contracting, but it's not going to shorten or lengthen its length. Okay? Your isotonic contraction naman, same tone. Isotonic, same tone. Same muscle load, same force, okay, or load is given for that muscle. The best example for isotonic contraction is holding an object in mid-air. If you hold an object in mid-air, okay, a same load is in your skeletal muscle. The same weight is in your skeletal muscles. There is muscle shortening and muscle lengthening, unlike isometric contractions. Okay? So special notes regarding muscle contraction that I want you to remember. Ano bang importante rito? Preload refers to the muscle length. Later on, we'll discuss cardiac preload. Cardiac preload is your end diastolic volume or end diastolic pressure. Afterload is the load against which the muscle contract. So, in cardiovascular system, we'll discuss the cardiac afterload. Cardiac afterload, meanwhile, is basically your aortic diastolic pressure. Okay? Rigor mortis, relevant in the med boards. Rigor mortis is the stiffening of the body 3 to 6 hours after death. Okay, faster in hot, humid environments. And it is caused by the lack of ATP. Yun yung tinanong sa board exams. Doc, ano pong nangyayari dyan sa rigor mortis? Okay. Changes to your body when you die. When you die, one of the changes in death is that calcium will enter the cell. So imagine your skeletal muscle, calcium from the outside will now enter the cell. That calcium can bind with troponin C. Once calcium binds with troponin C, tropomyosin is displaced. Once tropomyosin is displaced, it will expose the actin binding site. And once the actin binding site is exposed, myosin will attach to it. Okay? All of the steps I just mentioned, do not use ATP at all. They will just happen naturally. Okay? The one wherein you really need ATP, if you remember my discussion earlier, is the detachment of myosin heads from the actin binding site. Pero pag deads ka na, wala nang ATP. Ergo, hindi na magde-detach yan. Ergo, okay, pag dumikit na yung myosin dun sa actin, hindi na nag-detach, you will now have rigor mortis. Does rigor mortis last forever? No, it does not. Okay? Because one of the other changes in death is proteolysis. About 24 to 48 hours later, okay, magde-degrade yung proteins mismo, magpo-proteolysis, masisira. So when myosin and actin are degraded, well, rigor mortis will basically stop. Okay? So we've discussed this earlier, cardiac and ventricular action potential. Phase 2 is the most important for the ventricular action potential. It's the one that differentiates ventricular action potential from nerve action potential. Remember, in phase 2, we have calcium influx, okay, being equal to potassium efflux. So yung number of positive ions entering the cell is equal to the positive ions leaving the cell. Phase 2, plateau, calcium 2 plus. For the pacemaker action potential, we have phase 4, 0, and 3. Your slow sodium influx via IF channels. Okay. Phase 0 is depolarization caused by calcium influx. Phase 3 in your pacemaker action potential is repolarization caused by potassium efflux. Smooth muscles. Okay. Smooth muscles are like light switches. On and off. Okay? Much simpler ang mechanism yan. Paano yung mechanism ng contraction relaxation yan, Doc? Ganito lang. Napaka mababaw. Pag yung myosin head sa smooth muscle mo, may phosphate group. Pag siya ay phosphorylated, siya ay considered active or turned on and it will now cause smooth muscle contraction. Pag ang myosin mo walang phosphate, it's considered turned off and you will have smooth muscle relaxation. So, ganon ang smooth muscles mo. Smooth muscles do not have sarcomeres. Smooth muscles do not have striations. Smooth muscles do not have tropomyosin or troponin complex. Okay? Smooth muscles are actually stronger than skeletal muscles. 4 to 6 kg per square centimeter ang strength niyan, unlike skeletal and cardiac na 3 to 4 lang. Mas malakas ang uterus kaysa sa biceps mo. That's how I tell my students. Smooth muscles are stronger compared to skeletal and cardiac. Smooth muscles do not contract as fast as skeletal, okay, but they can contract for a prolonged period of time. Classically, I tell my students also, smooth muscles parang diesel engine, parang jeepney, or parang Fortuner na diesel, compared to skeletal muscles na gasoline engine. What do I mean by that? Ang diesel, mas matagal bago mag-init, mas matagal bago niya ma-reach yung efficient range niya. Pero, okay, mas malakas yung torque for the same displacement. Okay? So, ang smooth muscles, parang diesel, mas mabagal bago mag-contract, pero mas matagal niyang kaya mag-contract. Again, just think of the uterus as an example. It can contract for several hours. Ang biceps mo ba kaya yan? Hindi. Okay? So, smooth muscles will contain the following: myosin light chain kinase, MLCK, and myosin light chain phosphatase. Myosin light chain kinase will be the one to add phosphate to these myosin heads. So, myosin light chain kinase is the one responsible for smooth muscle contraction. The opposite, myosin light chain phosphatase, will remove phosphate from the myosin. So, it's the one, myosin light chain phosphatase, that will cause smooth muscles to to relax, smooth muscle relaxation. Calmodulin binds with calcium. It's equivalent to troponin C. Okay. Caldesmone inhibits muscle contraction. It's equivalent to troponin I. Okay. So multi-unit, unitary smooth muscles. Again, multi-unit do not have gap junctions. Unitary smooth muscles have gap junctions. Take note of the synonyms. The med boards, they're notorious for using synonyms that students are unfamiliar with. So unitary smooth muscles are also called single unit, syncytial, or visceral smooth muscles. Okay? Your smooth muscles, okay, again, how do they contract? There are three triggers for smooth muscles. What are the three triggers though? Neurotransmitters, like acetylcholine, epi. Okay? Hormones is another trigger. For example, oxytocin, the way it stimulates contraction of your uterus and your myepithelial cells of the breast. And finally, stretch. Stretching the smooth muscles can cause it to contract. Best example is the detrusor muscle of the urinary bladder. When the urinary bladder is 50% filled, about 300 ml of urine inside, it will stretch the detrusor muscles, the walls of your urinary bladder. When that is stretched, it will cause an increase in intracellular calcium, which will then trigger reflex urinary bladder contraction. It will trigger reflex urination. Okay? So these are the three triggers. Bottom line at the end of the day is that they will increase your intracellular calcium, which will in turn trigger MLCK to add phosphate to your myosin heads. When you have phosphate to your myosin heads, okay, you will now have muscle contraction. Okay? So take a look at this table now, this summary table. Some previous board exam questions, relatively trivial for me. They still ask. So I want you to be aware of them. Okay? Remember, again, napaka-imperfect na exam, unfortunately, ng med boards. Good people and Board of Medicine, but it's the system, okay, our laws which held us back in having good quality assurance mechanisms for the med boards. So some previous board exam question. Okay? Skeletal, cardiac, and smooth. Which one will have the greatest percentage of mitochondria? That is cardiac. Okay? Which one will have the greatest percentage of sarcoplasmic reticulum? Skeletal. Least number of sarcoplasmic reticulum? Smooth muscles. Okay? Poorly developed or lacking in atrial myocytes? Transverse tubules. Okay? So, we're now finished actually with two systems, not just one. Cell physiology and muscle physiology. I apologize, it's long. Binubukas ko na talaga lahat. Okay? More or less, even for the on-site lectures that I'm going to give, it's like this. Okay? Ganito kahaba at ganito ka-intense. Ang objective ko, okay, at least makover natin probably mga 70% of your handout. Yung mga self-reading portions nyo ngayon, sa gabi nyo siya gagawin after watching this video, okay? So, that's basically yung mga yung mga yellow boxes, yung mga MCQs natin from Physio BRS. Okay? And some of the other relatively less important concepts and principles that I've added in your handout for completion. Okay? Now, what I'm going to discuss sa lecture videos natin are the ones relevant to your careers as general physicians. Okay? Relevant to your residency. And some of the things that came out in the previous med boards to orient you on what's happening. Again, try to dissociate your feelings sa mga gumawa ng, hindi kami yung gumawa ng tanong guys sa med board. So, medyo mixed bag yan. So, hindi top-notch yung gumawa. Top-notch lang, okay, ang tumutulong sa inyo to adjust to those questions. Okay? So, it's going to be an imperfect exam. Accept that as fact. Okay? Rather than rant about it, okay? Just like when the water rises, so must the boat. Remember that saying? Let's make our adjustments. Kaya yan. Okay? End of the day, you'll still get good grades in physiology. If you have any questions, you just message me. So that's for our first module. Okay? The next module, neurophysiology, the ANS part and the higher nervous, I'll be the one to discuss, while the motor part and sensory part will be discussed by Dr. Franz Rubio. So thank you so much. Okay, welcome to our first module in physiology.